keyboard needs to be cleaned really bad because it does. That space bar is like, you really have to jam it. 30 on go 20. That's awesome, dude. Okay, wait, 30 go to 20. So if I just type that now, 30 go to 20. 30 go to 20. Run. Dude. Shift 4, okay. Shift 4 did not do anything. Magic. How do I stop it? How do I stop the program? Is that the end, run stop button? Okay, run stop. Sick. Okay, let's try one of these games. What do you think? This is actually pretty cool. Okay, Control C does not work. Yeah, so they had the run stop button here. Okay, so Control break. So do we have a control on here? I don't even say control, so I don't think we have a control break. So do I have to turn the thing off to hook a game up? How does that work? Cosmic Cruncher. Insert a cart. Okay, so let's just try one of these. I'm gonna try mole attack first. So should I turn it off, I guess? Okay. I don't want to move this thing, or maybe I should tape that composite to the bottom. Let me do that. Because I don't want it to come untaped or move. Well, I'll be goddamn. I guess there was a composite out on there. That's crazy. The thing works. Okay. All right. Our composite wire is secure. Nothing to worry about there. Okay, the cart. So we do that. The old NES trick. I'm assuming the picture faces up. I don't want to press too hard on it. Come on. Well, let me lift this keyboard. I can't see what's going on, and I'm trying not to force it. Excuse me. Thanks for the cheers. Thanks for the bits. Okay, we got the card in there. All right. Ready? Okay, now we're pulling about 1 amp. But I don't have a picture. What does that mean? So when this thing runs, does it boot your regular setup and then boot straight into it, or? This is a boring game. Joysticks, yes, I have joysticks. I got a couple different ones. These are 9-pin. Wait, these don't even go to it, do they? Oh yeah, there's one on the side right here. But it should boot straight into it, right? So why aren't we getting picture? Should I take the cart back out? Let me take the cart back out and see if the machine's still working. Gentle. Gentle. Okay. Okay. See if we still have our cart picture. Okay. What's happening here? Got our power light. It's pulling current. Still have that still there. Let me see if this thing needs to be reset back to that input. Of course, you can't see. Such a dodgy connector. Why don't we have picture anymore? You don't have picture! There we go. Okay. We're getting a flicker. Okay, let me tape this down again. I think we just don't have a good connection here. Because if I hold it in place, I get a good connection. All right. It's a dodgy connector. Let me see if I can redo these. I need it to go a little deeper, I feel like. Or the hole is a little bit thicker than what these connector or these pins are. Deoxit, yeah, okay. I don't know if I have any deoxit spray here. I mean, I got isopropyl, but that's all I got. Bigger wire would be better. I wonder if I could fold these wires over. Because it is pretty loose when I'm plugging it in here. It just kind of slips back out. Yeah, super. Oh, my wife calling? Nope. Got a message from Swindon. Okay, sorry. To check my phone. I'm going to fold this in half and see if it fits in there better. Don't get it stuck in there though. That's a good point. Another spammer. I didn't get a spammer this time, but I saw a message from somebody. Where's my pliers? So I'm just going to fold the end over. Just make it a little thicker. Okay. Let me just plug this one side in and see if that fits better. Yeah, that's better. Muy bettero. All right. Just solder the pins in there. Yeah, we'll go straight to the board and solder the pins right on. I can't believe we got a picture though. We got a picture. I can't believe. Okay. Okay, so they are in there. Let's see if it's working better now. Good. All right, so got that. It's a lot more stable. Blast from the past. All right, I'm just trying to unwind this. We're going to plug this game in. So I was just going to plug each game in eventually and just kind of get through all of them just to check it out, but I fixed it again. I have a picture. Okay, let's plug this card in. Oh, I hate how hard I have to press this thing in, but it's still basic. Oh my gosh. I don't have this thing screwed together, so it wants to fall apart too while I'm trying to plug this in. Okay. Okay. Whew. Man, that was a lot of work. That's not booting straight into the cart. What does that mean? Yeah, it's a tight fit for sure. Very tight. Never wrap a joystick like that. Look, we got a coil. I saved another Commodore. Okay, so bad cart. Okay, let's just go to the next cart. I don't know. Or do we need the 9-volt AC for that? Not enough voltage for the game. Let's see how much current it's pulling. So I'll put you on the screen here for that. Here, maybe I could put, let me give you that other view, the DMM. DMM? No, the BenQ, that's the one. Copy, reference, wide angle, we'll paste that in there. Paste reference, there we go. All right, so that way we can see the voltage. Capiche? Okay, so this is the current coming out of the power supply. All right, so when I turn it on, do we have this other cart plugged in all the way? We do, I think. Yep, all right. Load, I like that. Of course, the O doesn't work that well. Load. Press play on tape. So I don't have a tape thing, obviously. Run it without anything plugged in. Okay, you want to see the difference in current? Load game? Is that what the words I need to type instead? Okay, mismatch. Load star 7, 1. Really? So, do you think load star 7, 1 will work? Are you sure? We already tried run, doesn't work. What's the device of the cart? Load 8, 1 for the disk. So the cart is 7? Okay, so that's what we're saying. So load, oh my gosh, this 0 doesn't work, or O doesn't work. Load. I need to make this projector a little bit higher up here so you guys can see the bottom of this. Here we'll use, I'm going to use this as a spacer for the projector. Oh my gosh, these wires are everywhere. Okay. So load, space, shift 2, shift, oh no, star, shift 2, space, 7, comma 1, is that what you said? I need somebody else to tell me. Seven, comma 1. I don't have a 1. What do I do about that? 7, comma, no space, just 7, comma 1. So I would just do load space, and then that star, and then 7, comma 1. But I don't have a 1. How can I make a 1 come out of this thing? Hey, I got a 1, but now I can't go backspace. Let's see if I can get a backspace to show it. Okay, backspace worked. A 1. Let's see if I can get a 1. 1. Enter. Syntax error. Okay, so we'll try it again. So you're saying load, space, put it in there exactly the way you want me to do it. Shift, run, stop. Shift, run, stop. So shift, run, stop says play on tape. Then run, stop gets me back out of that. So shift, run, stop probably puts you back into what the last thing was, right? Okay. No load, run commands are needed, unlike a cassette. I mean, it sounds good to me. Okay, so we're going to do load. So all, no spaces. Load, shift, star, shift, 7, comma, 1. Enter. So I did no spaces. Okay. So we try one of these carts. Because these say Vic. This says Vic 1928, Vic 1912, 1933. I don't know what the difference is, but these say Vic 20s on them. Does that have a difference? Okay, everyone's saying it again. So now we're doing load colon star. So load colon. Oh. Colon. What did premise say? Darn it, I lost you. Star. And then another comma. 7, 1. Does that look good? Can you guys see that? So I got load, no space with a colon, quote, star, quote, comma, 7, comma, 1. I'm just doing what premise said. Try a different cartridge that works to find. Okay, I'm going to run this one. So we got no, you're trying to load from a disk. Okay, so that doesn't work. Oh, look, it did make it load from try to load from a tape though. All right, so yeah, we're not trying to load from a tape, we're trying to load from a cartridge. So let me turn it off. We'll try this VIC 20 cartridge here. Oh wait, this wasn't, that didn't seem like it was seated in all the way. Let me try it again. Okay, it didn't work. Okay, so let me try again. Turn off the insert. Wait, turn off insert card. How do I turn off insert card? Okay, so I'm going to try this fourth encounter game here instead. VIC 20 does not have 64K. Yeah, because it's old. Yes. All right. I mean, it may need that 9-volt VAC, right? For all I know, for the cart. Okay, well this game's doing something different. Or we have some sort of video scan issue. Oh, now it's just saying ready instead of saying the other stuff. So we got something different going on. Probably need the 9 volts for the cartridge to run. So now this is definitely something different. I'm going to unplug the cartridge and plug it back in. Oh, so now you want me to do run? Okay. It won't let me type at all. Well, I can't type, though. You don't recall your cousin ever typing quotes in the command. The cartridge is in a boot loop. Keeps going back to ready. Okay, so let me, and that's probably why it has the scan lines, right? Let's unplug it. Let's clean it. Yeah, it definitely has something coming out of it. No more power. Maybe a ROM issue? I don't know. You guys are the professionals. It's because I didn't blow on it. Okay. It's in its home. Wow! Hell yeah! That's what I'm talking about, man. That's what I'm talking about, Willis. Woo-wee! Okay. The 4th encounter. So we just need the old alcohol trick. Put it on overdrive. All right. So what do we do now? All I have is a joystick here. Let me turn off this light, see if that helps. No, that didn't help. Let's see, what about? Like, what light would help? We got rated by 87 viewers. Welcome, people. We're working on a VIC-20 that I picked up yesterday. Someone just gave to me. And we finally got it working. We had to make our own power supply to run it. And I have it working on an old projector because I don't have any other way of connecting it. But I don't know anything about a VIC-20, so everyone's trying to help me out. So, all right, so how do we start? Enter? What do we do? It's alive! Do you have speakers? I mean, no. Is there speakers in another one? Try another cartridge. What do you mean? I got this cartridge loaded. How do I go? How do I get going? Press the joystick button. I have 2 joysticks, so let me try another one. Where's my other joystick at? Here, hold on real quick. My wife's calling. Hello? No, I think we got it working, so we're okay. Yeah, thanks. All right, bye. My wife was going to bring over, I was waiting for that HDMI adapter. It just got delivered to Amazon, just delivered it, and so they were going to run it up here, but we got something working. So where is that other joystick at, though? What did I do with that? Give me a second. There was 2 joysticks. Ah, here it is. All right, so this one actually has buttons on it. This one doesn't. Well, I guess this one has a button too. And this is a 9-pin connector. Stop run. I can't do a stop run. Stop run doesn't even take me out of it. Shift stop run. Okay, let me reboot it. Usually the fire button. I'm just going to switch to this controller here. Okay, So we have this other puny controller. I don't like this controller as much. All right, the game is loading. Press a button. Nothing's happening there. To play fourth encounter of the VIC-20, insert the game cartridge. Turn on the computer. Press F1. What are you talking about, bruh? To access the shell menu. This is, that sounds like a ChatGPT answer because there's no F1 on here. Unless we're doing the F and the 1 key together. VIC-20 power supply. Obviously, we don't need the 9 volt because things are working unless you're saying the 9 volt is for this, but I think we're okay. We're still only using 1 amp. There's no F keys. Space bar. I like that. Space, enter, what else? Random keys on the keyboard. What about these keys? Oh, there's F keys right here. F1. F1. What? I'm sorry. I'm sorry I ever doubted you. I'm sorry. There's F keys right here. Oh my God. Okay, player 1. Player 1, go. Okay, here we go. How do we do this? I'm missing the bottom of the screen. Can't tell. It's so dim to me. What? Hold on, I can't tell. Am I right here? Let me see if I can adjust this projector a little higher here. Okay, here I am right here. And it's not doing anything. Oh, there we go. They got shooting, but I can't go back and forth. Okay, let me try the other controller again. Brilliant. It's like a Galaga. Yeah. Or Galagan. Galaxian. Galaxian. They keep exploding over and over again. It's like a explosion loop. Okay. Ah, this one's working. Brilliant. Oh no. F1. So play one player. Go. Yay. Oh, this thing works. This thing works. Whoa. All right, I wonder if we can get the other cartridges working now if we just clean them. Score! I saved another Commodore! All right, let me turn this one off. Let's try another game. Let's see if we can get something else working. Defender. It's almost a very Defender-y type of game. Okay, let me... Joysticks are hot swappable, apparently. It has plug and pray. All right, so that VIC-20 cartridge worked. Now, the question is, can we get these other cartridges working? So this Cosmic Cruncher, I don't even know what that was. The Mole Attack, we couldn't get that one to work, but let me clean the connections first. They'll need a nice cleaning. So just use some IPA. And then we'll see if we can get it in the load. Please stop plugging in the joystick. Oh, okay. Okay, well, thank you. So, apparently I'm not supposed to plug in the joystick when it's still powered on. Well, I won't do that anymore. But it did fix the issue. All right, machine is powered off. Mole Attack's going in. What do you think Mole Attack's gonna be all about? Press F1 to start. Start game. It's just working. Okay, I don't know what we're doing here. Is this like a whack-a-mole? Looks like a whack-a-mole game. Oh, it is a whack-a-mole game. So I have like a little hammer. If I can find where I'm going here. Or are you supposed to press the keyboard? Oh, it is a keyboard game. It's a whack-a-mole keyboard game. Brilliant. What do you think of that? No joystick needed. It's a fun family game. You could just use the keyboard itself. All right, we got that one working. Oh my gosh. Use the keyboard. Okay. Well, that one was fun. Oh my God, it's amazing. Premise, what did you just send me? Did you just clip something?
This thing works. This thing works.
Premise just clipped me. Nice. Thank you. Okay, what next? I can't believe we got this working. It's like Christmas. Okay, speed math and bingo math. Cosmic Cruncher. Sounds pretty interesting. What's home babysitter? What is this? I can't believe it works. I'll never play another game again. Yeah, it'd be cool if I could find some keys for this. I have the keys, but if I can make the pins, but I think that there's some sort of, you might be able to order them or something, I don't know. Okay. Yeah, I have the keys for sure though. eBay, $29.95, vintage Commodore 64 VIC-20 power supplies. So I can get a power supply for 30 bucks. It's alive. But who needs a power supply when we're using our 5-volt power supply here? And it works just fine. It's brilliant. Okay. What game we got now? That didn't like it. So we have to pull it back out. Clean it again. Oh, we need to get the sound working. So is there a speaker in this thing? Or is the sound out of this, and then we have to plug it into something? I don't see a speaker on here. Yeah, I don't see a speaker. So, yeah, to get sound out, we would need to take the sound out the back on the composite, I guess, and then connect it. We need another RCA cable with a, I have an extra one. I mean, we cut that one. We have two sides. But I don't have audio in. On this projector, there's only the composite in. I'll need a speaker. It's probably not amplified speaker. It needs to go to an amplifier of some sort. Let's think about that. But I thought a lot of these Commodore games didn't even have audio. Is that right? Because they were trying to save space? I guess there's a sound pen on the video port. If we go back to that video port plug. Oh, I can't see these buttons. Yeah, so audio is pin 3. So, but we need to go through an amplifier to do that. Let's see. Let me think about that. How do we want to get audio? I have, I mean, I have a speaker, but it's not going to be amplified. So it needs to be, it needs to go through something that can amplify it. Beeps and chirps. Sounds from the TV, PC speakers. I mean, I can probably find like a little tiny speaker because I have stacks of laptops that have laptop speakers, but portable RCA in. We have another one of these wires right here, RCA, but we don't have an RCA in. HDMI thing I ordered, yeah, that would do it. So I told my wife to not bring it up here because it's already 12:30. We're going to be finishing up the stream, so I'm not worried about like trying to rush off and get that set up. But if I solder to the other composite and then just hook the speaker to it, maybe we can do that. Maybe we'll hear something really low. Let me just grab a speaker real quick. Let's see. Let's get some speakers from a old laptop. I got stacks of laptops coming out of my ears. There we go. Okay. I don't even know what this goes to, but I just ripped it out of a laptop. I didn't even look what model it was. I didn't care. I was uncaring. So we'll snip this guy. Let's give it some space. Boom. All right. Try to shred it. Mic input on a laptop. Okay, that's a good point. So we could do a line in mic input. Well, let's see if we hear anything. I mean, if it's a fixed line out, then it's going to have a fixed volume that will be really low, but we might be able to hear something. Okay. And I'm just going to try to just hook this thing in here. It says they have 40 ohm speaker laying around. Yeah, 40 ohm. You can use an old 12-volt charger to take the transformer out and use to drop down the voltage. The IC chip is too small to amp this. I don't think it's going to be able to power it at all or make any sound, but let me just put a little bit of solder on the ends of these. We'll slip it in here. Fixed SID volume. Yeah, when you have that fixed volume coming out, you're not going to be able to really hear it. But sometimes you can hear something very, very low. So I'm just going to tin the ends of this and just try to shove it in the hole without doing the wire thing, because we're not trying to carry a clean signal. All right, so I'm going to have it off. And what pinout was it again? All right, so right now we're plugged into 2 and 4, and so number 3 is going to be pin 3. It's going to be on this side, so counterclockwise from that. Oh. Where did my speaker go? Ground is 3. Thank you for reminding me. So ground's 3, and then counterclockwise from that. So I'm going to pull out my ground. I'm going to stick that thing in there with it, and then put the ground back in. Okay, so both grounds in there, and then we're just going to shove this in number 4. Get in your home. This is your new home. This VIC-20 home. It's not thick enough. I'm going to fold it. Okay. Are you home yet? Yes, there it is. All right, it's in its home. Nothing's going to happen, I'm sure, but it's going to be a project for another day, if anything. All right. Got it. Ready? Nothing. Okay, hold on. Is this a game we've already tried? What game is this? Is this the Whack-A-Mole? I can't remember what game we have plugged in here right now. No, this is a different game we plugged in, I think, that we haven't tried yet. The Home Babysitter. Let's go back to a game we know works. I wouldn't mind this Fourth Encounters one, because that was pretty cool. It has 4 voices, really? Okay. Okay. Okay, here we go. Okay, let me stop. I have music playing, so let me pause that. All right. I don't hear anything. Yeah, so we're going to have an amplifier for this. Would you like to play a game? Whoa. Ah, okay. Pins 2 and 4, not 2 and 3. Did I do it backwards? Okay. Let me double check. Check my math. Check my math, people. I thought it was counterclockwise here. So there's the pin. I thought it was this counterclockwise first pin is going to be the positive, and then the center pin is going to be ground. Looks right. Looks right. 2 is ground, 3 is VCC. Well, I know, but it's not circular ground. So like 2 may be ground, but the center pin is ground. Oh no, things are falling over. All right, so there you go. So you can see right here, 2 is ground, 3 is this audio. So I have it hooked here for audio for those 2, and then I have this is ground and this is positive. I mean audio, I mean a video out. And I'm taking it as the notch here, so I'm going counterclockwise 1, right? Correct. So it's upside down from the picture, but we're going counterclockwise. We got the first pin is red to this audio. Then we have the center pin is going to be ground. That's correct. Yep. Probe with the oscilloscope to see if we have any audio. That could do something. Okay. And how much time do we have? Okay, we're at it's 12:40, so I'm going to be wrapping it up here in the next probably 10 minutes anyway. So we're just going to kind of play around with this fun little part. We actually got it working. We were able to get into the game, so I think we accomplished something today. I was going to give up, and you guys just said, keep on going. Keep on going, so I'm glad that I did. Let's get back over here. I think it should be the top right. I think I have it wired correctly personally, but all right, so I'm going to use this ground right here. And then I'm going to try to probe inside this hole. I'm going to take out the speaker. Are we getting anything? Come on. The game is on. Audio source is pin 3. Yes, it is. Okay, let's try again. Oh, there's something. That was actually like 5 volts or something? Was it a DC out? Let me calibrate it on my finger real quick. Hold on. So that's just like a DC out on that one. They're all kind of giving me that flat line. Need another diode. Yeah? Okay, let me shove a diode in that hole. Get in your home, diode. And maybe it's not playing audio on this this non-game screen either. I don't know. Okay. Remember, there's a 5 volt of the jack. Yeah, I do remember that. Okay. Okay. All right, so I have another diode that I'm just going to hook down in this hole. Get in there. Okay, that's connected. Now we'll connect to just the other side of that. So yeah, so I'm just getting a flat line there. Let me go into the game. Start the game. Oh, yeah, there's audio. Look at that. You see that? There's the audio. Oh. There's our audio. It's going with the game itself. Let me go over to the widescreen, but so you can see it actually show off with the game whenever it changes graphics. There you go. So we do have audio. I'll have to figure out some sort of audio source output. That'd be pretty cool. But if this HDMI adapter that just got delivered today works out, then we can actually play around with that and see if we can do some stuff. But both channels. Now we want both channels. No, I'm not going both channels. There's only one channel out, bro. It's only mono, because if we looked at the thing, we had a video high, video low, ground, positive, and then the audio. So, all right. So there we go. We did our VIC-20 challenge and got it working. And a lot of it was just like, how are we going to try to get it set up and working on some sort of modern day device? We even tried using a laptop with a capture card from the circa time, you know, or early 2000s at least. And we couldn't get that stuff working. But we were able to get the VIC working on a 5 volt power supply. We were able to set up a composite out just using the DIN pins in the back, and even found an audio signal using our oscilloscope. So I think it was a successful stream overall. Hopefully you guys were entertained by this, but I don't know what we're going to be doing on the next stream. Probably just fixing some laptops, because well, I feel a little bit out of my element working on things like this, but I like to at least, you know, kind of mess around, and I like to go in cold, like I said, like not knowing anything, but having everybody else kind of know more than me. I do enjoy that, and I know people enjoy me fumbling a little bit, right? You like that? So, but anyway, I'm going to call it a day. It's been a good, nice, almost 3 hour and 45-minute stream.
Hi everyone, and welcome to another episode of Mr. Carlson's Lab. Today we're going to electrically restore a pretty high-tech radio receiver from the 1930s. So high-tech, in fact, that many companies, even today, are still using this same kind of idea. This radio also has the ability to receive high-fidelity AM. So together, we're going to electrically restore this radio receiver, align it, and then we'll see how well it performs. We're going to make it perform like it did back in the 1930s. So let's get started. Here's the radio that we're going to be electrically restoring today. As you can see, for the 1930s, this is an extremely complex radio and was worth a lot of money. Really, this thing is a communications receiver in a wooden case. They did a beautiful job on the woodwork. This is all the original woodwork. And as you can see in the grill cloth down below, that gold looking grill cloth in the leaf, just the amount of effort put into that alone to make it look that good. All original. So this radio is an excellent example to do an electrical restoration on, and then we can see how this thing will perform. So after the restoration, this thing should perform just like it did back in the early 1930s. So everything works, all the dials and everything moves. So there's no problems with that. The little indicators for the fidelity and the volume on the top. So you'll see fidelity right here and volume. Little indicators move back and forth. There's two little sliders in there. It has a trifocal tuning electric eye. It's got all the neat stuff. So it should be a great electrical restoration. So what I'm going to do now is I'll turn this unit around and we'll take a look at the backside just before I take the cabinet out and get started. On the backside of the radio, you can see that big label that says Acoustical Labyrinth. So if you look into some modern day ideas dealing with sound, you'll find that some modern companies are using something that's very similar to this design that was used back in the 1930s. We look up just a little bit. You'll see the cardboard pipes running from the back side of the speaker down into the acoustical labyrinth. Right in the center of the speaker, right there, is an electromagnet. This is before speakers had permanent magnets. So the high voltage from the radio goes through that cloth cord, that big transformer on the corner there. The high voltage created by that transformer and rectified by that tube goes through this brown wire right here into that electromagnet, and it magnetizes it. So the current draw of the entire radio is usually placed upon that. Now, in some designs, it isn't, and I haven't looked at the schematic for this yet, so it may or may not run through that. Some of them will have a separate inductor in line with high voltage to filter out any type of hum or anything like that. So we'll take a look at the schematic here in just a little bit and see where they've actually placed the electromagnet down here in the electrical design. Lots of tubes on the chassis, very complex chassis for the 30s. Again, very expensive high-end receiver. So being expensive and high-end and in such good condition, this will be a lot of fun to electrically restore and see how this thing performed way back when. I bet you it performs very close to a lot of modern receivers. All right, I've got the back side off here, so I'll show you that. I've moved it out of the way already. Many screws later, lots of screws around the perimeter here and around the two cardboard pipes that run into the labyrinth. So I removed all that. So now this thing should just slide right out. And let's take a look at what's inside this thing. This should be exciting. That wasn't too bad. I thought this would be stuck in there, but it actually came out very easy. Okay, so I'll just slide this over here for a moment. We can see that we have a port on the bottom here, and it also looks like there's a bit of a port or a catch for the bottom side of the speaker as well here. So look at these pipes. That's pretty high tech for the 30s. Look at that. And if you look, you can see the path that goes down that way. And then there's an opening down in there. I don't know if you can see that. And it goes through kind of in a zigzag pattern through the labyrinth. So I know many of you are going to look this up. And again, you'll see some modern companies are using the same sort of idea that Stromberg Carlson was using way back in the 30s. Pretty neat stuff. Still really nice and solid and in excellent condition as well. So now what I need to do is disconnect the speaker. So I'll unplug this wire from the radio chassis and take the screws out because I can't service the radio unless the speaker is attached. Again, there's current going through this and into the radio, right? So the speaker has to be there when the chassis above, which is outside the shop right now, which is serviced. So I'll get all of that taken out, get this on the bench, and we'll take a look at the chassis and the underside. That's where the real interesting stuff is. The speaker is in really nice condition. You can see the seal for that box in the back side of the speaker cabinet there. The labyrinth, I guess you could call it. Big electromagnet. Some of the paint is coming off, not a big deal. You can see they've bent this nice piece of thick metal here, and they've used an arc welder to tack it into place. So very nicely done. Now the paper that they're using, it almost looks like it's plasticized, which is very interesting. It doesn't feel like paper. It feels like plastic, but yet it has the grain of paper. It's very interesting. It has a felt surround, really soft felt, and the travel of the speaker is very fluid. Lots of travel there. You can probably see it on an angle better. Lots of travel. There is no, got it from each side here, no binding at all. It's absolutely flawless. So when you come across an older speaker like this, you can actually adjust this in the center. If it's binding, you can loosen this off and readjust it by sticking shims down in here and then retightening it back up. That really makes a big difference, especially if the coil is touching the magnet, the electromagnet or anything. You'll notice that all the lows will go away and it'll kind of sound like, you know, you're talking with a pinched nose. Whereas in this case, everything is very, very fluid. It's working very, very well. I can see that right here. So the speaker itself is just in absolutely fantastic condition. It, you know, the surround is very soft, so this should develop low frequencies very nicely. So a really nice example of a you know, an old electromagnetic speaker right here. I don't know if it gets any better than this, to tell you the truth. That speaker is just absolutely fantastic. So I'll go grab the radio chassis because all of this stuff is almost too big to fit on this bench right here. So I'll move this out of the way and I'll go grab the radio chassis. We'll take a look inside and see what we're up against with that. Here's a look at the top side of the chassis, and as you can see, it has a lot of tubes in it. So these are all tubes here and here, all over here, here, and then there's a magic eye tube at the top. It's got this monster power transformer, which makes this chassis very heavy. And it's also difficult to get out of the cabinet because you have to bring the chassis back and then tip it forward. So you have to tip it on an angle because the dial glass in the front is so high that it actually doesn't come out of the cabinet square. So difficult to get out, and again, very heavy. Now this radio receiver has a lot of power delivering capability, so it can, I guess you could say, drive a speaker quite nicely. So these are the audio output tubes right here. You can see how big these metal tubes are. And they're 6L6s. So, you know, this thing is definitely going to produce some audio. Let's put it that way. They used a really big rectifier. It's a 5Z3 here because, you know, this thing obviously has some current demand with all of these tubes. So IF transformers over here, and of course we have the antenna oscillator and RF section over here. All the tuning will be, you know, this will be quite a job to tune this thing. There are a lot of spots to tune here, and of course with the IF being variable, it definitely makes for an interesting tuning job. So I'll just move this forward here. Man, this chassis is so heavy. So I'll just put this here. You can take a look at the dial face. So it's in absolutely fantastic condition again. So you can see they have dial strings here. It'd be nice if I could get all of this into the shot at the same time here. Okay, I think that's about good. So you can see all these dial strings here. And you can see that when I move this, you look at the volume up here. Now there's a light behind that, and it actually shows you your volume level here by moving this little red bar in and out. So a little disc is turning in there. And then the fidelity is the same way. So the fidelity control, you can see, moves up, and then it gets to about halfway, and then it hits a hard spot, but you can still move it quite easily. Now what's happening in here is there's a cam underneath the chassis that's moving slugs up and down inside of the IF transformers. We'll take a look at that shortly. There is a bottom on this radio receiver here, and I haven't removed this yet. There is only one screw in it, so we'll discover the fun together. We'll see what's underneath this thing. And yeah, the bottom is even in very nice condition. Very interesting choice of chassis paint. Really nice look to it. So I would move this around. This is just going to move around the dial indicator behind here, but I would need a knob on this to move this because it's, has a ratcheting function inside. So it holds it into each position of the selector switch, which moves this up and down. So it takes quite a bit of force to move this. And then of course this is just a, standard on-off switch and a potentiometer variable resistor behind it. So what I'll do is I'll flip this thing upside down. I got to do this very carefully. Have to be very careful with this dial glass and everything like that. And we'll take a look under this cardboard cover and see if anything has happened over time. It's obviously been serviced. There's a nice big hole here where probably some filter can has been removed or something like that. So it looks like it's actually painted. Yeah, I would imagine something was sitting there and has just been removed. All right, let's take a look at the underside. There's only one screw in the bottom here, so obviously people have been in here before. Not me. Somebody else has been in this thing. I have worked on these chassis before, but not this one. Look at this. Moisture resisting fiber. All right, no cost spared here. Whoa, no restorations done here. Looks like it's been patched up through time though. And look at this. Tar's even melting on that transformer. I'll grab the bottom here again. Let's take a look. Yep, there it is. Why is this here? Well, because of these. So what happens is these capacitors end up shorting out or becoming resistors, and they cause circuitry in the radio to draw a heavy current, and that heats up components. The components get hot, the tar melts and starts to flow. And you can see this one here has got a little bit of tar on it as well. So it's quite a ways away from the edge of the chassis here, so components have definitely gotten hot. This one here, really hot, so hopefully that's still okay. We'll find that out when we verify the radio. So the most common thing that destroys these old radio receivers is when these are purchased, people tend to grab these things and they bring them home and they think, oh, I want to just plug it in and see if it works. And when you do that, what happens is these capacitors, they end up shorting the electrolytics, and even these old paper and foil type capacitors, they end up shorting out, and they burn components out inside of the radio, and sometimes even the large power transformer that's way down in here. So if the power transformer burns out, that's kind of a crucial component on these chassis, and you have to end up looking around to find a replacement. Look at how hot this one has gotten. The actual color bands have changed on this. And, well, what's attached to this lead? A sealed tight capacitor. Sealed tight to keep the leakage in. So, definitely bad components all over the place. So anyways, what destroys these things is these cylindrical things right here. So all of these have to go. So this has to go, this. Oh, I can go forever. So there's a lot of them in here that have to go. So what I'll do is I'll remove these. These very easily come out. You just remove these screws here on this side and on this side down here, and then I can take these out, and I have a nice free area to work in here, and I can start replacing all of these components. This is the variable IF right here. You can see these slugs. There's a slug here and a slug over here that'll move up and down with this control. See that? How these are moving up and down? So there's a tone control here. There's a variable resistor here, and then this comes down here, and then we can move this up and down. This will change the fidelity. So we'll take a look at this on a spectrum analyzer. You're probably asking, why aren't you working on this on the bigger bench, on the old-time workbench? Well, reason being is because I don't have the 3585B spectrum analyzer out there, and we want to take a look at the IF in this thing. So I have to do it on this bench. So there are some original capacitors. This one here says Stromberg-Carlson on it. I can see the people that have put this together have actually spent the time to put the capacitors in the correct way. You can see outside foil mentioned here. That ties to the chassis. Outside foil ties to the chassis. And you can see here we have the outside foil end tied to the chassis. So they have spent the time to put this thing together correctly. So as I've mentioned before, whenever you're working on a radio receiver like this, it's worth the time to locate the outside foil on the newer style capacitors because they aren't marked. And I've designed a little device to do that, and I've released that, the plans and schematics and everything for that on Patreon. So you can take your new capacitors, locate the outside foil, and put in your new replacement capacitors the correct way. So they spent quite a bit of time to make sure that this is all done correctly when they put these things out of the factory. So you want to make sure that when you're doing your restoration job that you take as much time to do the job correct as well. Now what I'll do is I'm going to start replacing all of these caps here, and when I have that done, I'll come back and we'll talk some more about this. So what I'll do in the next shot is I'll tell you the amount of time it took for me to replace all of these capacitors. I.e., okay, it's been 2 days since the last shot, or it's been a day, because you really can't tell because in seconds it blends into the next shot, right? And then I'll give you an idea of how long it takes me to do this. Now, I don't cut corners and do the J-hooking method. A lot of people like to do that. They'll just cut the capacitor and leave a little bit of lead and then put the new capacitor in it and then J-hook the leads together. I don't do that. I'll actually remove the lead right from the terminal tie strip, and I'll put the capacitors in like they were at the factory. So I'll install them like that. So that takes a little bit more time to do that, but I prefer that method. So I'll get that all underway, and then we'll go through this and start testing some resistors. I'll even keep some of these capacitors out and we can test them, and I'll give you an idea of how these things fail. I'm interested in testing the Stromberg-Carlson capacitor. That's an original device right there, and yeah, it's put in the correct way. The band end is here, and that's right to the braid over here. So everything is, they spent the time to do this correctly, and even the people that were in here later on that did the work, like this looks like a replacement part right here, they even put that in the correct way too. So the technician that was in here at some point in this thing's repair history did understand that it's very important to do that. And I'll talk more about why it's important to actually put these things in the correct way, even though the newer capacitors don't have it marked. Just before I start recapping this thing, which at this point looks like an endless job, I was going to show you a modification that somebody has done throughout time. I don't know when this has been done. At any rate, somebody has cut one of the capacitors here and then tied some shielded lines in and, reattached it to the volume control so that you could pump some form of external music source or something in here at any rate. So I want to return this thing back to factory spec as close as I can so we can get a really good idea of how this thing sounded back in the 1930s. So all of these modifications are all going to be taken out, because when modifications are done like this, sometimes they introduce hum, even though they have shielded cabling, just because of their ground connections and things like that. And I don't want to introduce any other issues from other people's, in this case, scary looking modifications. Like this black tape up here, tape to a resistor, and all this kind of stuff. Green wire running off to here, just, some pretty scary workmanship. So this has been done over time, and this is very common when you work on radio chassis like this. A lot of the times you'll find yourself referring to the schematic to go, okay, so what's been done doesn't make sense. Let's try and figure this out, kind of thing. So I will show you the schematic here in a little bit, and we'll go over it, and I'll briefly explain the way that this radio operates. I have already gone over the entire schematic for this radio receiver up on Patreon. I spent a lot of time explaining all the different parts and sections in it, as there is a schematic series going on up there right now. So at any rate, I will go over it briefly here as well and show you what's been done and do a brief explanation of this circuit for all of you as well. Through the magic of the camera, what you see here is about 16 hours worth of work, give or take a half an hour or something like that. So it's been roughly 16 hours since the last video clip, and these are all the components that have been replaced in the bottom side of that chassis. And in a moment, we'll take a look at the bottom side of the chassis, and I'll show you how I've mounted all the new components. Now, you may look at this and say, well, you know, it doesn't look like a whole bunch of parts. Why did it take 16 hours? I was actually working pretty quick. Reason being is you have to move other pieces out of the way, and as you're replacing components, you're also testing other components that are attached to the same tie point, so you don't solder a new component in and have to go back later, test a component, and then remove, say, a faulty resistor. So for example, if this was tied to a tube socket and this was tied to a tube socket here, well, I'm not just going to desolder the capacitor, right, and then replace the capacitor and then come back later on and then test the resistor, find that it's faulty, and then have to desolder both of these again, remove this, put a new one in, and then resolder it. So there is quite a bit of time in just basically going through everything and testing all the components to make sure that they are close to value. Now, when you're replacing these components, you can optimize the design, and it's just due to the newer components. You can get grounds closer to where they need to be. Instead of running it to a remote part of the chassis, you can actually, ground it directly. Say if it's a bypass capacitor, you can go right from the screen to the cathode or very close to it on the chassis area. You can really optimize things, and that's just due to component size now. So for example, this capacitor here is the cathode capacitor on the 6L6 tubes. And this is located way across the chassis because of its size, right? You can see it's a pretty large capacitor. So this capacitor here is replaced with this capacitor right here, one of these caps. So you can see the difference in size. Now these have very good temperature ratings as well, so I can mount this very close to the socket of the 6L6 and ground it right beside it, which again optimizes the design. I don't need to carry a wire all the way from the cathodes of the 6L6 across the entire chassis and then mount this way far away. So things like that, and that really helps in RF service too. Whenever you're installing bypass capacitors in RF service, you want to keep them as close to the device as possible. You don't want long leads because long leads act as inductors, and they also pick up noise in sensitive applications. So I'll talk about that when I get the chassis here, and I'll give you some of my ideas and thoughts as I've gone through this and optimized things as I've been replacing components. Here's another capacitor, something like this here, brand new. We'll replace this right here. Okay, so, and they even get smaller than this. This is a fair size capacitor. You can get these capacitors, I guess you could say, size optimized as well, and I'm not really too worried about that. These are very long life, high temperature capacitors that I use. So I'm doubting that those will need to get replaced for an extremely long time. Very high quality electrolytics. I have entire lists. I've spent time grading, countless hours grading and testing components and verifying them in order to use in these older radio receivers so that it keeps the radio receiver working incredibly long. I have those lists up on Patreon. I have a couple of those verified components lists up there with part numbers and everything. So if you're restoring radios, that may be beneficial to you, because I guess you could say, a little bit picky about what I do. So what I'll do is I'll test some of these components here, and I'll show you where the real problems were. And just by removing these components and testing them, I can tell where the radio would have failed. So I don't even need to turn the radio on to do this. I can just go, okay, this is bad, so that means that this is going to happen. Or this is faulty, so this is the result of that being faulty. So what I'll do is I'll start explaining some of this. I'll get a schematic in the shot, and we'll test the famous death capacitor as well. So this is the capacitor that's across the AC line and tied to the chassis. Now these capacitors are, it's given a pretty strong term. They call them the death caps. But really what happens with these things is they end up short or becoming electrically leaky, and they bring the AC line onto the radio chassis. So this is that capacitor in that radio. We'll test this as well, and we'll see exactly what's gone wrong in here, and I'll explain all about all of these components here. So I'll go grab a schematic and some tools here, and I'll talk about that. And then I'll grab the radio chassis, and I'll tell you where I've replaced things and why I've done it like that. Okay, so here's the schematic. And for any of you that are owning one of these Stromberg Carlson radios, they're very cryptic about these resistors that are basically sealed in a block. They don't have any resistance ratings listed anywhere. So what ends up happening is capacitors fail in these radio receivers, and that resistor block goes open, and then you're left scratching your head going, what really was the resistance value there? So I've taken the time to mark that off. So any of you that have a failing one of these radios, let's say, that has that burnt out resistor block, and it's very common when capacitors fail and people operate the radios, right? So when this fails, these are the resistance values. So there's 3 resistors inside that resistor block, and I'll show you that here when we look at the bottom of the chassis. I actually just write right on the resistor, right on the little strip that holds it down, I write the resistance values. So in the future, if something ever does go wrong, it can very easily be replaced by somebody else or myself, right? So these are the values. So we have a 630 ohm resistor right at the top here. There's a 12K ohm resistor right here. And then this resistor is completely separate. This is the cathode resistor for the 6L6s right here. All right, so it's 2 resistors that are put together and then one separated one at the bottom. And those are the values. Again, I'll cover that when we look at the bottom side of the chassis. Again, I'll show you the resistor. I actually put a piece of thermal transfer silicone underneath it so that it will transfer the heat to the chassis and use the chassis as more of a sink. And it also keeps it tight in the bracket, because a lot of the times they come loose because just the plastic changes size over the years, and then they get a little bit loose, and then they don't properly transfer heat to the chassis anymore. Okay, so I'll show you that as well. Lots of little things that have been done in here. So this capacitor here, the death capacitor, is these 2 right here. So you can see it has a common ground to the chassis. I'll zoom in on this. I don't know, I've got my exposure fixed right now. I think that's going to be okay. So the brightness is staying all right. Okay, so that's the center connection, which is the shell of this capacitor. And then this is each capacitor. Each one of these leads is a lead off to the line side there. Now, as you can see, this is put together properly. Stromberg Carlson used their brain when they were putting this thing together. You can see the very first thing in line is the fuse, and then after that is the switch, and then after the switch are the capacitors. So if this ever fails, it's not right across the line at the line cord, it's beyond the fuse, so the fuse will go away if this was to say dead short across these 2 wires. Okay, a lot of new designs, they don't do that. They have the fuse in other places and things like that. You can even see there's a different version of the Stromberg Carlson that has a phono adapter, and it's kind of a skyscraper-y looking radio. It's a pretty sought after, very rare unit as well. And you can see that they've got the phonograph after the fuse and the switch as well. So everything is protected by that first fuse in line. That's very important in a good design. So this capacitor here is replaced with a modern X1Y2 rated capacitor. So there's 2 of them, all right, one for each one. They're X1Y2, so they have very good safety ratings. They're actually a certified safety capacitor. So when they fail in the correct mode. They don't, cause issues. Okay, so they're known as X1Y2 rated safety capacitors. If you're more interested in that, you can look those up. In fact, I have a bunch of those capacitors, again, listed on that verified. I believe they're in the verified components list. That may have been done after that. If not, it'll get added at any rate. So these resistors here are the ones that I just talked about, that long one on the back side of the chassis. These capacitors here have all been replaced by these modern caps right here. And then, of course, this cathode capacitor right here is the one that was replaced by these little guys right here. All right, my focus is right here. There we go. All right, 105 degree rated caps, long life, very important. Now, get rid of this thing. So these capacitors here, these 2 want to hang out together. So these ones here are down here. So there's one of them that's down here. All right, that's right across this particular unit right here and right to ground. So it's funny, they show a dot in the center, but they don't show it tied off to ground, but it is actually tied off to ground. So one of these caps right here, and there's a few things in the parts list here that aren't even listed, which is kind of interesting. The parts have a number on here, but they're not listed. i.e., part number 175 isn't on the list, things like that. Anyways, these capacitors here, this is a basically a 10 kilohertz filter right here. So to keep the highs, I guess at bay, you could say, because the IF in this thing is very wide. And with these two variable IF transformers, you're going to get some pretty high fidelity sounding AM out of this thing. So there's a bunch of these things in here. You can see I've replaced these here. Now, it's kind of a little bit odd because they use two different types of capacitors. You can see this one says mica mold on it. Okay. So the mica molds, these 100 picofarad capacitors, are leaky. Now, a normal capacitor tester won't detect this. So these look fine on a normal cap tester. Even on a normal leakage tester, they look absolutely fine. But these are actually leaky. They are degrading. Now, there are other capacitors in the actual radio chassis that say made in Canada, and I'll show you those ones there. Those ones are all okay. It's just these mica mold ones here that are, a problem here, especially the ones that seem to have the two leads sticking out. Here's another one here that was doing some work in the RF band switching section. Okay, so this one here, I had to remove this resistor from this one side here to test this, right, because this would act as leakage, right? And yeah, all of these mica molds here, they seem to be, creating a bit of an issue. So this one capacitor here was in the RF section here somewhere. Where was it again? It was this one here. It was this one here, and then there's a resistor across one of these right here. You can see this here. This resistor goes right across this one right here. So this was replaced with newer mica capacitors, right? Let's see, what else can I tell you here about this? There's so many parts and pieces all over this. These 47 k ohm resistors were moved up in value. The cathode bypass capacitor, this one here, is virtually open, so it would have really lost the bottom end response, and that's this capacitor right here, would have really lost the bottom end response, and the loudness effect would have really gone way down on this. This part here is a part that's gotten very hot, and of course that's because of failed components. This radio was being used, let's back this out here. This radio here was being used like this up until not long ago. So there has been heating in some components that would, it is definitely apparent, as I've mentioned before. And some of these capacitors are so incredibly bad. Some of the original capacitors in this unit are so incredibly bad. This thing was on the verge of a really catastrophic failure. So, and I'll give you an example of that here quite shortly. So lots of parts and pieces replaced throughout this entire unit. Whenever you're working on one of these radios, there's a little part that hides by the tuning eye, and it's usually right in the tuning eye cap itself. That one always should be checked. It's usually a 1 mega ohm resistor. So there are discrepancies in parts, in the parts lists of a lot of these radios. I've noticed lots of discrepancies in this as well. So I've gone with appropriate values that make sense to other sections. Now, it could be the discrepancy that I'm seeing has been a component replaced by a technician down the line. For example, when I was looking at this didn't look right. All right, so this 2.5 k ohm resistor is actually supposed to be 560 ohms. All right, so there would have been quite a bit of voltage drop across this one device, and it would have caused the receiver to be not as sensitive as it could be. Okay, so I replaced this with the appropriate value, and of course, we're yet to test this thing out. We'll see how it all works when we turn it on for the first time. This value here is one of those 560 ohm resistors. It's been very, very hot, and it's because one of these capacitors was very, very leaky. I believe this one here was attached to it. So this is one of those really horrible sealed tight capacitors. As you can see, it's had better days. So, and there's another one over here too. Different color, red solar sealed tight capacitor, high temperature molded capacitor that spits chunks of its molding off when it gets hot, I guess. You can see that there. At any rate, yeah, all really, really bad. So all of these capacitors here, no matter how you test them, are going to be, bad in some way, shape, or form. You'll find some that are better than others. And these are kind of odd because usually these capacitors are very good. Mica Mold makes very good capacitors. This may have just been a series. Maybe it's because they've molded 2 of them in one unit. That might actually be the issue with this. So I don't know why these mica molds are like this, but they are. Nice looking little capacitors. Now I always save all of these things. I'll put them in a bag and they end up in a box, and I can use these as reference in the future. And then when people want to know, oh hey, I have one of these capacitors inside my radio receiver, do you think it would be bad, i.e. one of these? I can go, yes, when I test these things. Now you'll test it on your normal tester and it'll look fine. But if you do an extensive test with the capacitor tester that I've created, you can really see the problem in this. I created that capacitor tester because I was working on transmitting gear, and some very high voltage mica capacitors were not showing any problems on any test equipment, even modern stuff. So I had to design my own piece of test equipment to find the problems, and it sure enough did. It found the problem. I replaced the mica cap, and the transmitter was back in service and nice and happy again. So anyways, I'll show you that here in just a little bit as well. So anyways, this is the, just a quick run over of the components here. I'll get some test equipment and I'll show you exactly why these things are failing and what's going on inside. Here's a very good capacitor leakage tester that's readily available on the used market today. When they're rebuilt, they're very sensitive and they work very well. However, when testing some capacitors, they just aren't sensitive enough, even in the mica position, which is the most sensitive leakage testing position that this capacitor tester has. Now, these capacitor testers, they put quite a bit of applied voltage across the device to test it. As you can see, this one here will put up to 600 volts across the device. And keep in mind the current is low, but that is still 600 volts. And caution needs to be used whenever you are using one of these devices. So if you ever do get one of these things, definitely follow the safety instructions that are, issued with the device. And it's always a good idea to keep it in the discharge position. The switches aren't spring-loaded, at least in this model it isn't, so it won't automatically pop back to discharge. You always want to make sure before you touch the leads or anything that it's in discharge and the voltage is turned right back down to its minimum. That's just a few extra safety precautions when using a device like this. So keep in mind, if you are going to purchase something like this and use it, you are definitely doing so at your own risk. Be careful. This device that I've designed is a low voltage tester, so much safer to use, and it's much more sensitive as well. It's designed to find those obscure issues. And I'll give you an example of that right now. So here's one of those capacitors that I've taken out that on this unit will test absolutely fine, but this one here will show the failure point. So I've mentioned this before, okay, in many of my other videos about these types of capacitors in the oscillator and RF section. If you don't have to replace these mica mold or mica capacitors in those sections, definitely don't do it. So you want to test them to make sure that they're not faulty, but if you don't have to replace them, don't just replace them for the sake of putting in a modern part. Reason being, again, as I've mentioned in earlier videos, is at the factory, many of these are hand-picked. And what they've done is they've optimized on the values to make the dial on the radio track correctly, if these are in the oscillator section. And even in the RF section, you need to be very careful with these caps. You don't want to be replacing these things unless they're absolutely necessary. So I hear so many people saying, oh, I just took out all the capacitors and I just replaced all the capacitors and I started from there. But now, 600 AM is somewhere around 650 and I just can't get it to, to line up. Again, a lot of these things, they were hand-picked to make sure that the dials track correctly. So something that may say 100 picofarad, that's what this means right here, 100 picofarad, may not necessarily be 100 picofarad if it's hand-picked. It might be 112. All right? So, and they're all of them that are used in those series of radios, they may have bought just tons of 100s and they just hand-picked all the 112s, and that made their radios work all that much better. So keep that in mind when you're restoring these old radios. These should always be tested and not just blindly replaced. Wax capacitors and electrolytics like this, you don't even think twice about. They can come out, right? Okay, so I'll give you an example of this here. So what I'll do is I'll attach the test leads of this to this capacitor here. All right. Now I don't want to hold the boots because this thing here has told me that these boots are mildly conductive. and I don't want to be touching those, so I'll hold the insulated leads here. So I'll click this on to leakage. If this is bad, that I should close. Okay. That's right up to 600 volts. So it shows it as being okay. Okay. So I'll turn that back down again and hit discharge. To show you that the capacitor tester is working, I'll just clip this here and I'll click this onto leakage. And as you can see, it's just, 3 volts, whatever. It doesn't matter where you go. It's faulty, right? Because it's dead shorted this way. All right. So you can see that. I'll test the other half as well. Okay, so I'll put that over there. All right. Hold these apart like so. Let it fall like that. Leakage. Right up to the top, 600 across it. Right down to the bottom. Nothing's happening. So it shows this as being an okay component. I'll click discharge. All right, always in discharge. So now I'll move this over to here. All right, so now what I'll do is I'll test this in the forecasting position here. So there's 2 scales that are indicated by these LEDs here. This is a newer release of the board. I've had many patrons that have asked, hey, can you give this a larger, more broad scale and something that can be calibrated to a resistance reading, and this thing can. So at any rate, this is one of the newer designs. So what I'll do is I'll put this here. All the designs work. Any one that you make works. This is just, I guess you could say, something that is more optimized if you want to actually, get an idea of the actual resistance of the device or where it's leaking. So I'll put this across here. Again, I won't hold the boots because the boots are mildly conductive and this will pick it up. So I'll hold it back here. Okay, so this is in the forecast position. So if it's red, it's really bad. If the scale is yellow, it's on the second scale down towards the green light here. So this is discharge. Okay, so it's green. And then I'll click it onto test now. There you have it. It's showing the issue. You see the light's red, and we're only 1 LED in from the end, so that's just over 1 gigohm. Okay, so this can count all the way down here yet before this goes green. So I'll hit discharge. Okay, and here we go again. This is a faulty device. So I'll test the other one. I'll shut it off, move this over to here. I'll test the other capacitor on here. And just make sure that nothing is touching. Okay, so here we go. And that one's just a little worse than the other one. Okay. Oh, no, it's coming down a little bit. It's still very bad. So they're very, very close together at any rate. So now to give you an idea of how a good capacitor will test, so this is 100 picofarad. Okay, so if you were to test this on a normal capacitor tester, you're going to grab just a normal cap tester here. Let's move this up here. I'll put this on the 200 picofarad scale. What you're seeing is just its own capacitance here between these two things. I'll just plug 2 of these in here. So I'll bend this lead out of the way, and I'll just plug these 2 into the fixture here and get my hands away from it. If it'll fit. These are some pretty thick leads. There it is. Okay. So there you go. You can see it's in there. It tests at 108. So you'd think that it's okay. The capacitance is okay. But it is turning into a resistor. So what I'll do is I'll pull this out of here and I will give you an example of this capacitor. So this is another mica capacitor. This one here is 100 picofarad. Same kind of deal, 104, all right. So what I'll do is I'll put this one into these leads now. Now keep in mind that this here is just another mica, just like the other one. This is just a different package. Okay, so there you go, in the leads. Now watch what happens. Look at that, no problems. That's beyond 40 billion ohms. Shut that off. That was through the discharge, and one more test. No problems. Okay, so that's how most capacitors are. All these micas should test in the forecast position. See if I have another one on the bench here. I do. I've got one off the side. What is this one? 3900 picofarad. Okay, so this one here should be 3900. Let's see what it reads on here. Make sure I am not leading any of you astray. I'll put this in here. It should be about, And go up to 20 nano. Yeah, so there you go, 3.87, so 3,900. 3.87 nanofarad or 3,900 picofarad, very close to, okay? All right. So let's test this one. Now this one here is quite a bit larger in value. So let's test this one here on this. Okay, so no problems. Again, discharge. And here we go. No problems. So you can see if I just put my fingers across it, you know, I make the machine look like, or think that I'm a dead short here. See how bad this one is. This one is rated at 0.1 microfarad. So put this in here and click leakage. Wow. So there you go. This one's leaking at 6 volts. And this one is rated at what? $200. This is rated to go to 200 volts. All right, so this one is really effectively turning into a resistor. So let's see what this does here. Back down to 3. Let's see what it does on this. Still on the test position. Let's hold that up there. Yikes. So the second light, between the first and second light, we're looking at, you know, 10 megohms of resistance. This one is really bad. See, that's going to be about 10 megohms of resistance. That's only one light into the red, into the bad scale. So this is really bad. So this is virtually, you know, a dead short up to a megohm. This is around, you know, 10 megohms are in that area here. So I'll just shut that off. Let's, for the fun of it, let's just take a look at this. Now keep in mind that those things are across the supply lines in here, right? And these are the ones that just destroy the radio. So I'll turn this on. Get my leads here. Turn this on to ohms. Give it some brightness here. Hopefully you can see that. I'll move the focus onto the screen just in case it's hazy. All right, so here's our cap. Let's read its resistance just for the fun of it. So it should be in the area of 10 or something like that. Look at that. So it'll keep counting for a while. So now you can see, like, we're at 3 megohms right now, and it'll probably settle off. If I let this sit for a little bit, it'll, you know, settle off somewhere. This other cap, maybe this tester here may actually give me a quicker reading. I know that that really doesn't apply a whole lot of current. So here, let's try this one. Maybe I can get a quicker reading on this. So go here and here, and we'll go, say, to the 20 megohm range. I'll put this here, and let's see if we can get any kind of a quicker reading off of this. So there you go. We're at 6 megohms. Almost 7 megohms. All right, here is a good 0.1. So you can test this here, see what happens. You'll see it's just an open connection, right? You'll go, right, see, it's open. All right. And if we test this with the other meter, which goes way up into the megs, we test that with this one here. Now this is only going to apply a very light amount of current. Let's see what this does here. This here and here. Beyond 500 megohms right there, right? The reason it's climbing up slow is because it's charging the cap, right? So it's beyond 500 megohms, which is absolutely fine. You know, and of course these things test great on these capacitors here. These are all on that verified parts list. You'll notice that radio has a ton of those inside of it. So at any rate, there you have an example of why you may possibly want to build something like this. So if you do want to build this, all the plans are up on Patreon, and you'll find out that this thing is very beneficial to have on the bench. I use this continually. In fact, just for the fun of it, as I'm removing components, I actually test it with this to see how bad they are. And as you can see, that one there, it may settle off, around, well, this is what, just about 7 megohms, something like that. It'll settle off around that area. The first light's about 1 megohm to a short. The second one will go to about 10 and a bit, and then the third one is going up. And this here is just about 1 gigohm, and then when the scale flips again to the yellow, it's a gigohm, and that's all the way to 40 billion ohms this tests. So if there's any leakage through moisture ingression in any of your capacitors or anything like that, this detects it. That's the reason I had to build this, is to fix that transmitter. And that transmitter, as I say, no problems. In fact, it's still in service. So no issues whatsoever with that thing. Now, keep in mind, all the previous versions that you've seen to this test this pretty close to the same range as this one. This one has one extra added range, so you can see when capacitors are charging. That's why it's a dual color. They're all on Patreon. All of these things I've created are up there. So if you want to build something like this for yourself, you can do that. And of course, the foil side tester is there as well. This is the tests for the outside foil. I'll give you an example here. I do this with every single cap and mark them, because these ones don't have the outside foil listed. So I'll turn this on and hold my hands up here. I'll insert some noise into this cap. So the LED with the least amount of LEDs lit indicates the foil side. So this is the foil side. See? Noise and no noise. Okay, so the least amount of LEDs with the LED here that's lit indicates the foil side. If I touch this, I ground myself out. That's the reason you can see I'm doing this here. So I'm acting as the noise antenna for these things. This is up there as well. So this is an adjustable sensitivity setting for all sorts of different capacitors, and it also has an intensify position here for those really, really sensitive ones that you're having a hard time locating the outside foil on. You can see how just clear that is, right? So outside foil, this side. So then what I would do is I would take this capacitor here and then take my little fancy pen here, if I can get the cap off, and then put a little dot here. Just like so. And that little dot now indicates the outside foil end, and this is marked for use. So to give you an example, even though these capacitors are leaky, they will have an outside foil. So you can see that this one here clearly marks outside foil on one side, outside foil. All right, so put this here and this here. And so this side here should be the least amount of lights again. Hold this, get a little bit more hum into it. Not much. There we go. So that's the least amount of lights on that side. You see the outside foil isn't as pronounced on this older capacitor. It might also be that I have the sensitivity way up as well. There you go. So least amount of lights, the corresponding LED is the outside foil end. And again, it's this side right here. And as you can see, it says outside foil. So if I flip this around, you'll see the effect on the other side. Okay, so I'll just remove this. And I'll turn this around. So this should be now the least amount of LEDs, indicating the outside foil end is on this side, right? See that? So it's flipped around now. Again, very useful for when you're working on radio gear to put these things in the correct way, especially for bypass service and things like that as well. Another project that's up there, ready for you to build with all the plans and schematics and everything. So that's just 2 of them. I have a lot of these little devices up there that I've designed. So if you feel that these may be beneficial to you, definitely head on to Patreon and check those out. For those of you that have never seen resistors like this, they read just the same as normal resistors, except their coding is a little bit different. So if you can remember bed or bell, you can very easily decode these resistors in the future. Bed is very easy to remember. Body and dot, or bell as in body and line. So the body is the majority of the color. So the body is yellow on this, which is 4. The end is purple, which is 7. And then the line is orange, which is the number 3. So you can directly convert that last one into zeros. So 4, 7, and then 3 zeros. So 47 k ohms is what this is, or 47,000 ohms. Now, a lot of these are body and dot, so there's just a little dot on the body. They don't have an entire line drawn around it. Either or, pretty much the same type of deal. All right, so let's test this one here. This is the same type right here, so we'll just go across this one here. And as you can see, that's a long ways away from 47 k ohms. It's 55 k. Right? That was replaced. Here's another one, same value. Look at that, 61 k ohms. So these are way off, right? This one here was supposed to be 560 ohms was supposed to be. Somebody had replaced this, and it turns out that this one here is 220 ohms. So all the colors are burnt on this, and this is most likely from that bad sealed tight capacitor, nothing else. There's nothing that should really heat this resistor that hot. So this one right here is the reason that this one got so hot. So this was dragging, there's B plus on one side of this, and then of course this is dragging the other side down, making this thing change color. And even the color bands have changed. It's hard to read now. So that was replaced. And then this resistor here was in a spot where there should have been another 560 ohm resistor. This one here may be okay. So that should be 2.5K. That's 2.8. Not too bad. At any rate, so this was replaced with a 560 ohm resistor again. Now, that's just a sum of them there. There's more of them that are scattered around the bench here and everything like that. So those are way off. Now, keep in mind that no fourth band or anything means that these are all 20% tolerance. So, depending on its application, if this was 55K, it would be okay in some applications. But whenever there's current passing through this, and it's, say, supplying a screen section or something like that in a radio where there is a bit of current demand on it, if it's supposed to be 47K ohms, it should be replaced with something close. If you lower the screen voltage on certain stages, you'll also lower the sensitivity of the receiver. And of course, when you have resistors like this in the wrong area that are, a lot higher in value, let's put it that way, that definitely needs to be changed as well, because there's going to be quite a bit of voltage drop across that resistor. And of course, again, the receiver sensitivity is going to be affected, again, especially if it's powering up the screens in the radio receiver, or say it's in line with a transformer that runs to a plate of one of the vacuum tubes, something like that. There'll be a lot more drop across this than there would be a 560 ohm resistor. Here's the bottom side of the chassis with all of the replaced components, and as you can see, they are everywhere. All of these yellow devices are all brand new capacitors. These are all brand new caps over here, all of these electrolytics. You can see the resistors that have been changed. This is that one that got really hot. And there's the 47K ohm resistor over here that was bad, another 560 ohm here. All the caps, these are lots of electrolytic caps have been reinstalled. They're all over the place. These are the new caps that are across that 10K filter in the audio section. There's more of these under here. I had to remove this little tar-filled transformer, tar-coated transformer. Just the amount of work that's gone into the bottom side of this thing is very incredible. The known death capacitor that used to be here is now replaced by these two components right here. In fact, I forgot to actually show you how bad that cap is. It's over here. Maybe we'll revisit that here in just a little bit. This is the death cap. So it is very leaky. So these are the X1, Y2 rated caps across the line there. I left the original line cord in because it's flawless. The original cloth cord is soft and it's absolutely flawless. Now this line cord is not to be confused with a curtain burner. This is not a curtain burner line cord. This is it has solid wire in it. You'll hear the term curtain burner. What that is a resistive line cord. So the actual line cord of the radio receiver itself is a resistor, and that was used in some of the early series sets to create a drop across the line cord so that the tube filaments in the radio gets the correct supply. So again, those resistive line cords are known as curtain burners. Now they look a lot like this, but this is a standard line cord. It's just standard copper wire in this. So no problems there. And again, it's flawless. Like the line cord's not even a nick in it. It looks you know, completely fine, and it's soft and pliable and flexible. So it's kind of nice to leave that on there because, again, it, you know, just maintains the original view of the radio on the outside. So that's really good. What else can I tell you about this? These are these made in Canada caps here that are just absolutely fine. There's no problems with those. And zoom on into that. You can kind of see that. So made in Canada right there. Those ones seem to be okay. Now, mind you, a lot of the waxies were made in Canada as well. I think the Stromberg Carlson ones were made in Canada. And of course, anything, see, made in Canada, these things are just horribly leaky. So these are really, really bad. So the micas are okay. The paper and foil caps are the exact opposite. So those are very, very bad. So lots of work done under here. The filter caps that were in here have been replaced by these modern Rubicon capacitors. They're very, very good capacitors, put it that way. Oh, this is the resistor on the back that often fails. That resistor I was telling you about that they don't give you any ratings for in the parts list or anything. So this is it here, and as you can see, I've actually drawn in, it's on a bit of an angle here because of the way the radio is sitting, but you can see I've actually just written down or drawn in the resistors where they go and put their values there, right on that little strip. You can see on the back side here, I've taken a piece of that, basically it's thermally conductive silicone. It's designed for putting semiconductors against heat sinks and transferring the heat to the heat sink. So it's resistive, and I've also put that underneath here. What happens is, over time, this plastic body of this resistor, or the compound that they're using at any rate, shrinks up a little bit, and the bracket gets loose. So by putting this underneath here, it acts as almost like a cushion, and in the tight spots, it's very tight, and it also, it can expand into the areas that aren't so incredibly tight. So it makes nice thermal conductivity all the way across the entire resistor body to the back. And, it keeps everything nice and cool. So that's just something that I normally do. And there's no heat sink compound or anything on it. It's just, that piece of heat transfer silicon underneath here, and it's tight on there. Like, it just, it's really tight. So that'll keep that in very good condition. If this isn't bad and you replace all the caps in here, chances are this will not go bad. It's just the capacitors that destroy these things. Sometimes I've seen holes burnt right in these things. And what happens a lot of the time too, they get so hot in one area that it chars the area, and that area becomes conductive, and then the actual resistor from the B plus section, it makes somewhat of its own resistor because the material has gone conductive to the chassis, and it just makes everything all that much worse. So they burn holes in them and everything like that. So this is a nice barrier between that and the chassis as well on that one side. So it's just a win-win situation doing that with these resistors here. That is pretty much it. That's all that's done here. And, on the bottom side, at any rate, I haven't cleaned the band switches yet, and need to still spray the switches with contact cleaner, and I will do that. And the next step after that is to basically turn the thing on, see if it works, see what happens. Oh, one thing I didn't do either is I didn't check the little resistor where the eye tube is. Why don't we do that right now? I don't know if you can see that. Get that right into the shot there. Let's see. I'll grab a screwdriver here and open this up, and let's see what it is. Too big. And see, where is the correct size? That is a little small, but it'll work. Okay, so these just usually pop open. Just pry them up. So a little bit of area around the side there. You got to be careful. You don't want to break anything. See, there's a little index here as well. So when you put it back together, you want to put it back together so that index lines up with that. There it is. See if I can just pop that out with my fingers. Nope, that is pretty tight. Yeah, it's pretty tight, all right. Let's see if I can get behind the second layer here. That should give me a little bit of leverage. There it is. Okay, there is that hiding resistor. That's 1 megohms. Again, body end dot, brown, 1, end is black is 0, and then green is 5 zeros. So that's 1 million ohms. Okay, so let's see if this is going to be okay. Grab my meter. from across the lab because I wasn't expecting on doing this. Let's see what happens. Does it need to get replaced or not? Turn this on, just lay that in there. Get a bit of the glare off that. Okay, let's see what happens. That pin to this pin. 1.55. Not good. That needs to get changed. So 1,500,000 ohms. So that's already halfway to another meg. So that needs to go. So there you go. So if you ever have an iTube that's not as sensitive as it should be, you definitely want to change this resistor. And as you can see, this resistor needs to get changed. Again, it's, halfway to another meg ohm again. So 1.5 meg ohms is way too high. This should be 1 meg, in some cases even just a little bit lower. So I'll change that out and I'll go grab the speaker. I'll flip the chassis over and we'll see if the thing receives anything. All right, place your bets. What do you think's going to happen? So do you think this thing's going to work, or do you think we're going to have some magic smoke? Hopefully not. So before I did anything here, I put 2 knobs on these 2 controls here that are a little bit hard to turn. This one here is the IF bandwidth, and when that little arm comes over to move those 2 slugs up and down inside there, it does get a little bit rough to turn. And of course this one here is the band switch, and it has that little ratcheting effect. So I put 2 just junk knobs on here, and the other 2 are just plain. I can just twist these around with my hands. I stuffed the eyeball back in the top here. Hopefully that'll stay in there. Just held by the springs loosely. And yeah, hopefully it's gonna look okay. I think it is. I don't know. I'll find out. Stay. I might have to twist it around. I don't know if where the angle is, the shadow angle is, right? Because I haven't turned the thing on yet. Okay, so this is plugged in my isolation transformer and current limited variac supply, and I'm ready to go. So I just want to make sure that the volume is down. It is. As you can see here, the little volume moves up and down. I want to make sure everything is just down before anything happens. Okay, so here we go. It's on. That means that this switch is definitely on. Look at that. Alright, so just wait till the tubes warm up. Aha! I see a green glow. That's a good sign. So it does have B+. The rectifier in the back here is working. That's washing out a bit because that's a very bright eye. So I'm just going to turn that around until it looks like it's somewhat supposed to be there, like that. So it's just loosely in place there. If I shine a light on the face here, it won't wash out so bad. You can see the eye a little bit better. But, okay, so I'll try and get that down here so it's not totally ruining the look of the face of the radio there. Okay. I can already hear radio stations happening here. So this is the volume, so I can turn this up.
Driver's seat for that top seat. So if they
wow. Not much eye action happening here. Wow. Lots of bass. So that's with the IF bandwidth down at the bottom here. Let's find something here.
Geeky breakdown.
So what I'll do is I'll turn this up here. I should hear a lot of treble come in.
Winterizing. Yeah.
Leading up to Thanksgiving to keep gathering.
going to develop in the to Peggy because we try to come up with these.
Wow.
Or not. Because in 30 states...
Craig, we should point out that it's some porn. That's all I want.
Wow. So it's really, really sensitive. Not bad, and it sounds so full. Amazing. The bass, this thing is rattling this speaker down here. So the 6L6s are driving that speaker very nice. So let's try another band. Let's see this one here. Looks like the switch or the bulb might be not all that great. Get that out of the way. This is a little bit brighter. So let's see if we have the WWV at 5 megs. Look at that. There's no RF alignment or oscillator or anything here. That's the time signal at 5. So this band goes down to 1.7, so I can get the 2.5 in here as well. Let's see how close it is to 2.5. You think you're so slick, radio? Let's see if you come in at 2.5. Okay, so here it is, 2.5. Okay, this is ridiculous. This thing hasn't even had an alignment. That's the 2.5 megahertz time signal. Okay, so this is 5.6 to 18, so let's see if we can hear anything at 10. No, this is 10 right here. So chances are I'm going to hear my own oscillator because I have a 10 megahertz standard in here. So I'll probably hear that. There it is. Wow. I think at 15. That portion of the band is out right now. Wow. Lots of bass in that. Okay, so let's go down to, I guess, the beacon band. Roll up here. That's a beacon right there. Wow. Wow. Well, the oscillator is pretty close. The oscillator itself on this thing is pretty close. So obviously the person in the past, this wouldn't be the original alignment, I'm sure, has done an okay job. I would be very interested in the IF, knowing what's going on with it, because I noticed that when the IF bandwidth is narrow, it takes a lot to cause the eye to deflect in order to have a full deflection, so that the eye comes together, the two halves come together on a strong signal. It doesn't seem to do that with the bandwidth very, very tight like this. So I don't know if you can see that in there. I'll just get the light off. You can kind of see that. See how this moves up and down here. So with the IF bandwidth, they say low, fidelity low, so the bandwidth is very tight. The eye itself has a rough time deflecting. So I don't know if that's an IF issue or something like that. We'll find that out. So if I go to broadcast band here, so this is the bandwidth again. Let's see some volume. So you can see the eye doesn't really want to move all that much. Whereas if I like,
It's a funny hobby because
you can see if I widen it up,
let me ask you.
it's more sensitive when it's wide than it is narrow, which is kind of interesting. So that might indicate that the IF is definitely out of tune. And of course the RF section in here might not be as sensitive as it should be as well. So that would, cause this to be like this. Now this has, 2 IF amplifiers, right, and 3 IF transformers. And the reason that it has the extra IF transformer is because when you broaden the IF bandwidth, of course you lose sensitivity. Well, in this case, the sensitivity seems to be going up as we broaden the IF bandwidth. So the IF just might be really out of tune. So I'll get this thing attached to a spectrum analyzer, and we'll see exactly how things are. So I have to tune these little adjustments here. There's an adjustment here and an adjustment at the top, and then there's one at this one here and one down here, and then there's another IF transformer as well. So these little adjustments here are what I'm going to be twisting. Let's see, actually, just for curiosity's sake, if these are live. So let's see. I'll grab my voltmeter here, and let's see if these are live to the case. Sometimes they have B+ on them. So I'll turn this on to here. I'll put this up here for a moment. Very carefully. Let's see if I touch the chassis and this. No, they're not live on this. That one isn't anyways. So that's a good thing. I warn people about this a lot. Some radio receivers, the actual adjustments in the IF transformers are live. They have full B+ on them. So if you have a metal screwdriver, which you can turn these with just a standard metal screwdriver, if you turn these with a standard metal screwdriver, and if they were live and you slipped and touched the case, I don't know if you remember the game Operation, something like that. So, you know, this thing will end up, you know, shorting to the case and you can damage the IF transformers. So you got to be careful around devices like that. These here aren't live, so it's kind of nice. So putting a screwdriver in is not going to be too big of a deal. Now, using a metal screwdriver in all cases is not possible, especially whenever you're dealing with powdered iron slugs. These are just capacitors, and you know, this obviously are attached, you know, to either the chassis or whatever. So the magnetism of the screwdriver, of a metal screwdriver in there, is not going to affect these. Now, a lot of the times, again, if you're going to be adjusting these things, and you can use a metal screwdriver in the capacitors, as long as it's insulated and you know it's not live, it's the better thing to do, because you'll break your tuning tools in these. These are, you know, just big screws screwed into a capacitor here. If I had one of these caps out, I would show you. It's just a, you know, a big threaded screw that tightens some plates together inside of a cap here. So normal tuning tools will get absolutely destroyed if you try to twist these, because normally these are very tight. So again, it's all about balance. Use a normal insulated screwdriver where possible, and then, you know, save your tuning tools for what they're actually needed for when you're dealing with powdered iron slugs and things like that. For those of you that are interested in knowing how I attach my spectrum analyzer to a radio receiver to do a sweep of the IF section, here it is. This is also valid if you want to attach just a standard sweep up to this, like using an oscilloscope and a sweep generator. This is the way that you do it. So first of all, you can see that we have the modulator tube here, which is just another name for mixer tube, and we have two input grids on this tube here. Now, normally, when a tube symbol like this is drawn, they have a little cap on the side indicating a cap, but they haven't done that on the schematic for all of these tubes that have caps. So what I've done is I've just drawn that in here. So the RF runs through the RF amplifier, through these coils here, and then up in this line into the cap, and that's the line that I'm going to be feeding the signal from my tracking generator of my spectrum analyzer. So there's a signal that comes out of my spectrum analyzer. All right, so the spectrum analyzer is running to the input line here. That's what SAN is. So the tracking generator puts a signal onto this line, and I want to put that signal into here. Now, I'm going to leave the oscillator running while I'm doing this alignment, and I'm also going to lightly couple my spectrum analyzer into this circuit. So when I'm attaching the signal into this grid line here, I'm not going to directly couple the output right to the cap. I'm going to clip the signal lead to the insulation of the wire running to the cap, and I'm going to very lightly capacitively couple into that grid. Now, the trick or the key to a successful alignment is to make sure that your test equipment remains invisible to the device under test. If, for any way, shape, or form, you heavily couple into a very sensitive tube like this or section like this, what you're going to do is you're going to drag your own alignment with the test equipment. And what you'll find yourself doing is you're going to align the IF section, and you're going to compensate for the mistake of heavy coupling. You definitely don't want to do that. That is the difference between a good and a bad IF alignment. Now, the trick to the whole thing is that when you're doing this, if you heavily couple in and you're, say, compensating for that by tuning these IF transformers, when you take your test equipment off, you don't know that you've heavily coupled, and the moment that you disconnect your test equipment from this, your IF alignment changes, because the capacitance and inductance added by your spectrum analyzer, the way you've coupled it in, is now removed, and that changes the way the IF looks. So very important to remember whenever you're dealing with an IF section and anything that's as sensitive as this, especially this line right here, you need to extremely lightly couple in. Now, what I've done is I've created some little boxes here. I've released this on YouTube. I believe it's under a spectrum analyzer protection device. You can look in my list of videos and you'll see how these are built. It's right here. It's released on YouTube. At any rate, my spectrum analyzer uses these boxes in line with the input and the output. So output of my spectrum analyzer being the tracking generator, and the input of my spectrum analyzer being the 1 megohm input of my 3585B. So what this does is this protects the input. This one here protects the input of my spectrum analyzer. So what happens is there's a limiting network in here with some diodes, and there's a whole bunch of capacitors in here that allow me to effectively keep everything flat during the IF frequency. So the boxes are flat within the IF range, and it is a very tight range that these are flat in, but it allows me to protect the front end of my analyzer. So if I was to say, for example, accidentally touch this to some high voltage, I'm not going to take out the front end of my spectrum analyzer. If you burn out the front end of a spectrum analyzer, it's not like burning out the front end of an oscilloscope. If you burn out the front end of a spectrum analyzer, you're going to have a very bad day. So you don't want to do that. So I'm very, very cautious around the inputs and even the tracking generator output of my spectrum analyzer. There's another box like this that attaches to the spectrum analyzer output or the tracking generator, and it just says 50 ohms and high Z. It looks exactly the same as this. So it just protects the inputs and the outputs, and it's also an attenuation network in here so that I can properly tune these stages. Now, these boxes are purpose-driven or purpose-built, and again, you can check out how I've built these things right here on YouTube. Just look under my list of videos. Now, I haven't released the circuit boards or anything at this point yet, and I guess I should because I get asked for this all the time. I have another email today about, putting these things out. So I think I'm going to do that. So I'll probably add the files to Patreon as well. So if you want to build these things yourself, you can put some of these things together. So what I do, again, is I clip the signal lead just to the insulation of the wire that goes to the cap. And then, of course, the common just attaches to the chassis, and that'll feed signal into here. All right, and then what'll happen is by the time it gets through the IF amplifier into this stage right here, this is where I pick the signal back off, and this goes back into the input of my spectrum analyzer. Now this goes to the 1 megohm input of my 3585B, and I'm clipping it directly to the insulation again on the detector lead right here. This is a relatively high impedance point in this radio receiver, and that is very easy to drag. So again, with the isolation and attenuation of this box right here, this is the actual box that will be attached to that. I will just clip this right to the insulation of the lead, and this will clip right to the chassis, and that will pick up the signal and allow me to align this without dragging anything. That will give you the best alignment possible. So I'll get this all hooked up, and we'll take a look at the spectrum analyzer screen, and let's see how close or how far off the IF alignment actually is. All right, let's see where the IF is in this radio receiver. Let's see if it's close or if it's in outer space. So we know that the center frequency of the IF for this radio receiver is 465 kilohertz. Since this is a high fidelity radio receiver, I'm going to want a span of about 20 kilohertz. I'm going to want to see 20 kilohertz worth of width. So that means that if the center frequency is at 465 kilohertz, my start frequency is going to have to be 10 down from that, which just happens to be 455 kilohertz. My stop frequency is going to need to be 10 up from 465, so that'll be 475 kilohertz. So I'll set that up right now. So the start frequency will be 455 kilohertz. The stop frequency will be 475 kilohertz, and that puts the center right at 465. So I'll just leave everything the way it is right now, and I'll turn on the radio receiver and let's see what happens. I'll have to make some other adjustments here. Let's just see where we're at. I also need to put this to the 1 megohm input, because that's what I'm on right now. There we go. Well, already I can see that I'm way off. So if I move the marker around, you can see a little marker right in the center here. If I move that around, you can see this is the peak right here, and that's where the center of the IF is right now. So we're right around 470 kilohertz. That's pretty far off. So what I'll do is I will adjust the dB per division here. 10 is a little bit, well, it's a little bit too much. So I'll bump it down to, say, 5 just to start off here. So the dB per division, 5 dB. That looks a little bit better. Now, in order to find out where this actually is, or to get as close as we can, what I'll do is I'll just press signal track here for a second. That'll bump everything to the center of the screen. And then, of course, it'll keep the span the same. So I'll just go signal track, and I'll shut that off. So there we go. The center frequency is right dead on, 470 kilohertz. Look at that, right there. So it's 5 kilohertz high, perfectly. So that is way off. So what I'm going to do now is I'll adjust the fidelity control on the front of the radio receiver, and that should expand this. So we should see this widen up. This is on the narrowest setting right now. Whenever the IF adjustments are done, that needs to be done on the narrowest setting. And then once the IF is peaked up and everything's done, you can kind of critique it on the widest setting to make sure everything just looks good and everything flows properly. So what I'll do is I will widen this up. So I'm moving the fidelity control right now, and I can feel that little detent just starting to hit the cam right now. So I'll keep turning. And as you can see, I'm getting that gain. And I'll keep turning this, and I'll just stop this right about here. All right, so it stops hunting. What I'll do is I'll zoom on into the screen, and that'll give you a better idea of what's going on here. Right about there is nice and close. Pardon the shaky camera, I'll just adjust the focus here. And there we go. So that's at its widest setting. That's looking pretty messed up. So what I'll do here is I will narrow this up again, and as you can see, it's shifting. So you can see the peak is right in the center right there. Now you'll notice that as I showed you earlier, when I narrow the IF bandwidth up, the eye isn't working as well. Okay, so this is the narrowest. Now you can see as I'm widening things up, you see how that is rising on the screen? It's going up right now. As that's rising, what's happening is the IF section is becoming more sensitive. You can see that amplitude is coming up. Now as I get to the top, this is about the peak, and if I look at the front, it's about 3/4 of the fidelity control. So now if I keep going, you can see that it comes down again at its widest setting. That's at its widest setting right there, and as you can see, it's pretty wide. So again, I'll turn the fidelity control back down here so it narrows things up. You can actually see it, the peak is moving off center here as well. And then as I bring it back, you can see the peak, it kind of squeaks towards the center of the screen, and it gets to about the center right there. But you can really see the gain reduction. That's why the eye isn't working very well. So narrowest, and you can see, you know, keep in mind, this is 5 dB per division, right? So this is, if you want to see that, I can go here and look at this right now. It's 4.26, right? And I'll, like, look at how much that's coming up, right? So the peak would be about, what, 29 millivolts from, and that's from just coupling in right, you know, on the insulation of the lead. So we're down at 4, and we can get all the way up to 29 millivolts just by moving the fidelity control. Okay, so there's huge gain reduction there. So there's a lot of, you know, it's really out of alignment. So what I'll do now is this is the narrowest setting right here. So what I'm going to do is I'll just put one of my screwdrivers. You remember, if you recall earlier, I measured the capacitors on the front of those transformers to make sure that they're not live. What I'm going to do is the one that I measured, all right, I'll put a screwdriver in there and I'll just give it a bit of a twist, just that one, and let's see what happens. Okay, so it's in there. This is really hard to work around the tripod here. The radio itself has got adjustments on the front side, on the side, and on the back of the radio, which makes this extremely hard to do on camera. Not only that, to get the spectrum analyzer in the shot, it's sitting right in front of the radio receiver right now. So what I'm going to do is I'm going to make an entire, I think I should probably make an entire series on tuning radio receivers, doing the IF sections, and I'll have to create some, you know, other bracketry to hold cameras, and I'll go through that, the entire tuning procedure. unfortunately, in order for me to completely tune this up, I'm going to need to do this off camera. The camera will have to be right out of the way, and I'll have to be moving the radio chassis around in circles in order to adjust this thing. It's just the way that they've set everything up. Some of them are on the rear, and the tubes are in the way. So I gotta move everything around. Okay, so here we go. I'm gonna move that bottom capacitor. So you can see I'm moving the gain around, and now you can see I'm actually shifting the center. So what I want to do first of all is tune for the maximum at 465, so I can move this here. It actually shifted it in the right direction. So right about there. So if I move the marker over, see I'm about 468 now. You can see how much that shifted it. So I'll move the capacitor in the top side of that, and let's see what happens when I do that. All right, if I can get my screwdriver in there. This one's almost behind the dial glass. This is okay, so give this a bit of a twist. Wow, look at the amplitude coming up. So right now, by doing this, as you can see it rising on the screen, look at that. That's sensitivity. That's receiver sensitivity that you see happening right there. Lots of sensitivity added just by moving this around. So right about there is its maximum sensitivity at about 468. So you can see, just by tuning those two capacitors, how much this is already improved. I've actually shifted this closer to where it's supposed to be at 465, and the sensitivity has come right up just by tuning two of those capacitors, just two of them. And there's another two transformers, so that's four more of these that I get to tune in order to bring this up. So it's way out. You can see that it's absolutely way out. So when this is done, the eye should work very good, and I should get a very nice even spread on the IF when I'm done. So chances are it'll probably have a stage curtain effect. So you get the double hump kind of happening on here. And once I've got this all perfected, I will come back and I'll show you what I've done, and I'll explain it. To give you an idea of usually how long it takes to do an alignment like this, you're looking at, in order to perfect everything, to make it look as even and to get the best results possible, it usually takes me about an hour or an hour and a half to do this. And that's just moving back and forth between capacitors and just making sure that everything is right where it should be. And of course, you want it to look just as good when you're widening things up like this. You can see it doesn't look too bad there. You can see the double hump right here, right? But that's just, that's nowhere near the end of the fidelity control. Like, that's the end of the fidelity control, okay? So you can see that it's starting to look a little bit more like it should, and that's just by tuning those two capacitors. So you get the stage curtain effect, the double hump happening here. So again, I'll get all of this done, and I'll show you exactly how this should look, and then we'll be on to the RF and oscillator and antenna section tuning as well. Tuning the IF section in the Stromberg-Carlson took about an hour and a half, and that is an hour and a half of me moving around those 6 variable capacitors in those 3 IF transformers. Now, I have to tell you that getting the IF to work the way that you're going to see it here on the screen without using a visual means would be absolutely impossible with this receiver. I'm telling you, if I look at one of those variable capacitors out of the corner of my eye, this pattern that you see on the screen will change dramatically. That's really how sensitive it is. It's so sensitive, in fact, these radio receivers sounded fantastic when they rolled off the factory floor, I'm absolutely sure. But the moment that somebody changed one of those IF tubes or even the detector tube, this pattern would just change. You wouldn't have that same quality of sound that you would have had when this thing came from the factory. I'll give you an example of that here in just a moment. So you'll see that the center of the screen is exactly at 465 kilohertz. Now what I'm going to do is I'm going to widen up the IF bandwidth, and you're going to start to see that stage curtain effect. Now, the whole trick of making these IF alignments work the way they should is to keep that double hump falling and rising evenly. So the stage curtain effect, those two bumps you're going to see on each side, they need to fall and rise evenly as you're moving around the variable IF bandwidth. So as those two slugs are moving up and down inside those two IF transformers, they need to basically work with each other correctly in order to get the sound. All right, so I'll give you an example here. All right, so I'm coming right to where this little detent is now touching the cam to where it's going to start moving those slugs. So here we go. Now keep in mind that this is now at 2 dB per division. I had it at 5 dB before, but at 2 dB you can see much more detail here, okay? So now you can see how it's widening up, okay? Now you can see how I'm getting the stage curtain effect. You see how we have those two bumps on each side? You see how they're forming evenly? That is a very difficult task to achieve, because you'll get a bump on one side and it'll maintain, you know, a flat mark on the other side here. So what I'll do is I'll move this down to its widest IF bandwidth, and as you can see, they fall evenly, and as I raise this, they rise evenly, and then they form the perfect bell curve in the center. And then as we come to our narrowest bandwidth, you can see the amplitude dropping just a little bit. Now that's absolutely normal, right? And keep in mind, we're also dealing with only 2 dB per division here. So what you're seeing is very, very minuscule. So making this happen, just like you see right here, and then falling evenly, like this, is the result of about an hour and a half of tuning. That's going back and forth between all of those capacitors and making sure that I maintain the 465 center, and then I have those two bumps forming on either side. Now this is the best it's going to get. You'll see right at the center, right at the very center of the dip here, I'll just move the marker around. You'll see right at the very center here, you can see the little marker moving around there. So you can see that the center is off really just into the hertz, right at the bottom, right? So absolutely fantastic for an IF section that was designed in the 30s. In fact, this is really quite amazing how well Stromberg Carlson put this together. So what I'll do is I'll give you an example. If I just I'm telling you, touch, I'll just move this back to the center here again, so it's right at the center. If I just push on one of those capacitors with a screwdriver, watch what happens to the pattern here, okay? So I'll just get over here, and I'll put a capacitor, or a screwdriver in the capacitor, and I'll just press on it. See that? Now, if I was to give this a twist of a hair's width, we'll say maybe a millimeter. Look at that pattern. The pattern is immediately destroyed. We're talking moving that hair's width. All right, so I'll adjust the IF here so you can see what's happening. So you can see it forms somewhat even at the center there and comes back down. But then once we start to widen it up, we get one bump that's way off to one side. So our peak sensitivity will be off to one side of the IF. And as you can see, that's just really in outer space right now. That's by moving just one of those 6 capacitors a hair's width. So you can get an idea of how long it took to actually figure out how to make everything track and, just have a good pattern here. So I'll put this back in here and I'll try and get this adjusted perfectly again. Probably have to spend some time with this to get that right where it needs to be again. We'll just leave it there for now. And I will move this around. So we'll see this rise. That's very close. It forms right at the center. And that's the narrowest bandwidth right there. So as I say, doing this by just a peaking method or using a VTVM or something like that would be impossible. It would be absolutely impossible to get what this is doing right here. So this radio receiver with that IF that you see there will sound fantastic. It will sound like an FM radio when it's wide. So what I'll do here is, since we're at our narrowest position here, what I'll do is let's calculate to see how wide the IF actually is. So I'll just make sure that that's at its narrowest point. It is. So I'll adjust the reference volts here and just bring this up to the top line. So we'll go here. That's pretty close. So if we go 24.5, and that's 21. So let's say, we'll say 23.5. Let's try that. 23.5 millivolts. That's a little bit too high. Let's go 24. Go reference volts 24 millivolts. And that's very close to the top line there. Okay, so what I'll do is I'll turn on the display line, and I'll move the display line right up to the top. So if you look here, you'll see that this comes to 0 dB right at the top line there. Okay, so since this is 2 dB per box down, I need to go down 3 boxes. All right, so I'll move this down 3 boxes, and as you can see, right at, you know, minus 6 dB right there, and this is where they normally measure the IF width. Okay, so I'll go back to the marker, and I'll move the marker off to one side, and I'll put it right at that line. Okay, now we're at 467.08. All right, so I'll get my calculator here. So 467.08, and then we go take away. So I'll go to the other side now. $462.92. 462.92 equals. So we're dealing with 4.16 kilohertz of bandwidth. Not bad. That's pretty narrow, so it's very decent for communications quality stuff. So that's going to allow us to really narrow in on frequencies that have, you know, other frequencies very close to them. So we can, you know, really just get rid of all of the adjacent frequency noise. So it's pretty decent, not too bad. And that's at 6 down. Usually I measure them at 3 down, right? Because 6 is actually being kind of generous. They were always kind of generous doing that. But we'll just stick with the 6 because that's usually where these companies measured them. Okay, so 4.16 kilohertz wide in the narrowest position. So now let's go to the widest position and see what happens here. So I'll have to probably bring this down to center screen here. So reference volts, bring that down to about here, and I'll bring this back up so we can adjust this here in a moment. Okay, so oops, bump that controller. Let's go here. So we're at 15.1 and 17, so let's try 16. 16. That's pretty close. Close enough. All right. All right, so we're still at the 6 dB down point. You see the display line here is still at the 6 dB down. So if I go to display line, you'll see minus 6 dB right here. That's this line, again, 3 boxes down, right? 2 dB per box. All right, so what I'll do is I will roll the marker back over here. All right. I bumped the display line. It doesn't matter. I'm using the graticule anyways. So go back to the marker. So right there, we're at 475.6. Okay, so we'll go 475.6, take away, over to the other side now. 454.560. In fact, I might be able to move that down just a touch right there. So 454. Let's see. Get this as accurate as possible. Right about there. 454.560. All right, take away 454.56 equals 21.04 kilohertz wide. Pretty fantastic for an IF section. So go divided by 2 equals 10.52. Okay, so this is 520 cycles above their audio cutoff filter that they've designed on the underside of the chassis. Can you say Stromberg Carlson did their homework? What a fantastic job. We're only 520 cycles above. Right, so it's 10.52 each side of the center. This radio receiver will sound absolutely fantastic. So there you have it. That's how the IF should look in one of these radio receivers. Keep in mind, if you're ever going to align something like this, you need to make sure that these things fall and rise at the same time. You want to maintain symmetry as close as you can to their design. And again, you can see that the center is out just a touch, but it's in the hertz here. If we move this right here, see the little marker here? Technically, that would probably be the dip right about there. You know, so not a big deal. Not a big deal at all. It's so close. For IF transformers designed in the 30s, this is ridiculously fantastic. So anyways, let's get on to the other portions of the alignment. I'm going to perform the antenna and RF alignment in this radio receiver. I'm not even going to bother with the oscillator adjustment because the frequencies, as displayed earlier, are spot on. And it's, yeah, this thing is so incredibly close. I've actually never come across a receiver that is this close without me doing an alignment on the oscillator section. So these are the oscillator adjustments here that don't need to be touched. This is the RF adjustment here. You can see RF written there. This is the RF adjustment. So in that box there is the RF coil, and these are the tuning capacitors. And this is the antenna adjustment right here. So I will adjust this one here and this one right here for the broadcast band. So I have my signal generator set to 1500 AM or 1.5 megahertz. And I'm at 100 microvolts. So I'll just move the dial to 1.5 megahertz here. 1700. That's so ridiculously close. Listen to that. It's spot on 1500. And that's with the IF width narrow. It's right on the line. Again, I've never come across a receiver that's ever hit the bench that's been so in tune that way. It's actually kind of surprising. So now that the IF section is done, we can use the I itself as a tuning aid. So I'll just tune this off frequency here again, and I'll show you that the I is functioning correctly. And I shield some of the light from it there. Maybe a little bit. Okay. So there it is. So I can use this as a tuning aid. I don't even need to hook up a VTVM or anything like that. Now the capacitor that's in this circuit here, the time constant for this is a little bit slower than I would like it to be. I'm almost tempted to modify that in the design. I'd like this to respond a little quicker, but that's okay. Okay, so what I'm going to do is adjust the antenna section here and just tune for a peak. So I want this to come as close together as possible. And I have a feeling this is probably spot on as well. Okay, so let's see where we are. Oh, no, I can use a bit of a peak. Right there. And then I go over to the RF, which is right here. I don't think I can aim for this without tipping the chassis here because it's right underneath the camera. So I'll just move this like so. And put this in there. It's a really big chassis, really awkward to work with here on camera. Okay, and I'll tune the RF section. So again, we're tuning for maximum closure. Right there. The thing is really spot on. Now, if I was to touch the oscillator adjustment right here, it would just tune this thing off frequency. That adjusts the dial tracking. So I definitely don't want to be touching that because when I say this thing is spot on, it is spot on. So this eye tube here is looking okay, but it might be a little bit tired. I think I might just grab another eye tube here. It's nice and bright, but doesn't seem as sensitive as it should be. So give me a second here. I'll just unplug the eye tube. And I have another one here across the lab. Okay, so here's a brand new one. This is a JAN type 1, Joint Army and Navy 6E5. So this is going to be a really nice tube here. Plug that in, let's see if that's any better. This is brand new, so it might take a few moments to come to life, so to say. Some of the light off of that there. Yeah, it's definitely closer together. I'll just move this off frequency here. That's definitely more sensitive, and it's quite a bit brighter as well. So I think I'll leave this one in there. That's very, very bright. Very nice eye tube there. So now what I'll do is I just have to go to the other bands, do the exact same thing, just basically rotate the band switch here, like that, and then go to the next band and tune it. So I'll start at the bottom, I'll start with band X, and that's these adjustments here in these cans. Here, I'll see if I can show this to you. Oh, this thing falling off the bench. That's a ridiculously awkward thing to work with. That's tuning these right here. And then I just have the rest of them to tune, which are here. So, very simple alignment. Everything, as I say, the whole oscillator section here seems to be right on frequency. So the person that was in here last really did a good job in aligning the RF and the antenna in the oscillator section, but wow, that IF was in outer space. So everything good except the IF really was aligned okay by the previous technician. Another portion of this radio receiver that has been most likely detuned over time and never retuned properly again is this 10 kilohertz audio cutoff. So there's a little filter network down here, there's a little inductor and a capacitor across it that's designed to cut off the audio after 10 kilohertz. So this is between the last audio amplifier and the grids of the 6L6s. Now, there are no instructions on how to adjust this in the alignment procedure, so that's something that was done at the factory, and I guess they just expected you to leave it alone. I would imagine way back when, Stromberg Carlson had a sweep setup for the audio section in this as well. So I'm going to use my Stanford Research SR780 to sweep the audio section, and I will make that adjustment so that we can cut that audio off after 10 kilohertz. I'll get that set up, and I'll be right back. The Stanford Research SR780 is attached to the radio receiver, so the source output, or the signal coming out of the Stanford Research SR780, is fed to the wiper of the volume control. And the input of the SR780, so the signal going back into the analyzer, is just picked right off the voice coil of the speaker. So I have the sweep set from 8 kilohertz to 12 kilohertz, and that should get us within the range of this adjustment here. And we should be looking for a dip or a null around 10 kilohertz. So I've got the marker set to 10.02 kilohertz. The reason it's sitting at 0.02 is just because of the number of points I have here. If I up the number of points, it'll sweep slower. And the slower sweep is painful to work with, so we'll just leave it here. 10.02 is close enough. So I'll turn on the radio receiver and wait for the tubes to warm up. And the analyzer is set to auto range, so it should pick up where we need to be here. Let's see where this thing is sitting. Oh, we see something on the screen here. So we can see the dip or the null is actually quite early. So let's see where it's sitting here. It's sitting around 8.5 kilohertz. That's no good. It's supposed to be at 10. So I need to move that dip over to this line over here. So what I'm going to do is insert my screwdriver into that adjustment that I just showed you. And I'll give it a bit of a twist. Okay, see which way are we going? Oh, that's the other way. We don't want to go that way. So let's try the other direction. Now I have to wait for the analyzer to catch up because it's a slow sweep. So we're going in the right direction. That is a good sign, and there is quite a bit of adjustment room here, so that's good. Well, just about there. One more little tweak. Oh, I passed it. See if I can see how far I can actually go here. Whoa. So you can see I've completely passed it, so I'll back the control up until that dip is right in the middle of that line. So every time the sweep goes past, I give it just a bit of a turn. So let's see how close we are here. A little bit more. A little bit more. I'm just moving this control a hair. And I think that's it right there. That's looking pretty close. So let's up the number of points here. So let's go to, let's try 500. Enter. And I can probably move the marker. I think that's as close as I can get right there. 10.003. It looks like it's spot on. That is a slow sweep. Yep, it's right in the dip. The radio is all put back together. Let's cruise around the broadcast band and see how this thing sounds. So hopefully the mic will pick this up. I have it pointed towards me, so it'll hear me, but it is a really full sounding radio, so let's get some volume here. You can see as I'm turning the volume up, it moves that little scale up over there. It has this little red dot on one side, which seems to be almost a perfect volume all the time. So that's kind of interesting. Okay, here we go.
Research Institute life-changing outreaches.
Government officials on the program again. You'll have the guests you need. Sports news note and long-term care workers in every area of the province.
Incredibly full sounding radio, and that's not even at the most fidelity.
People, countries banning travel. Thank you.
Very full, like stations absolutely everywhere. The radio itself turned out very nice. I'll give you a view of the front of the radio here. You can see the nice gold leaf in the grill there. It turned out really, really nice. I cleaned up the wood just a little bit. Basically really didn't need too much, right? So that worked out well. So let's try another band here. Let's see. We can go to the beacon band. This is aircraft beacons down here. So what I can do is zoom in just a little bit more. Actually, no, this lens is going to allow me not to zoom. So let's just give this a shot. Let's take a look. Give us some volume here. There's another one here. And that's right down at the bottom. Not a whole lot down, around 145 kilocycles. That's way down at the bottom. That's way below the IF frequency of this receiver here. So it stops at about 360. This is 370 right here. I think 360 was the last. That's far enough away from the IF so that, yeah, 360. So it's 360 there, and the last would be 370 right about there. So, yeah, it's way, way, way down there. Now, they have police written here, but I think that's for the next band up way, way, way back when. So let's up the fidelity just a bit, and Let's see here. Maybe I can find something to give you a better example of how the high fidelity really sounds on this. Problem is that you need music to do that, and we know how that works on YouTube. So let's see here. If I can find just a station that has pretty clear talking.
Biblical language and go to great lengths to concoct commonalities. However, the alleged similarities as well as the terminology used to communicate them are clearly exaggerated.
Isn't that fantastic? That's full fidelity. It sounds like the person is sitting right in front of me. It's just incredible. So I'll just go to the next range up here. And let's see, these ranges, the higher you get in frequency at this time of the evening, it gets really quiet. I'll see if I can find, let's see if we can find the WWVB, or WWV, I should say. The VB is down at 60 kilocycles. This to WWV should be at 2.5 at this time. There it is. I don't know if you can see the action of the eye. It's kind of blown out here. Let's see if I do this. All right. And I'll just... Now, if you remember the IF curve way back when we were doing the alignment, you get a certain way through the fidelity, it comes to a peak and then it comes back down again, and you can really see that with the fidelity control, even with just the noise. So what I'll do is I'll bring this to the start. Okay, so this is the start of where the cam is just touching the slugs. Now, as I increase the fidelity control, you'll see just from noise, the actual eye will close. So that's its peak right about there, and then as I go to full fidelity, it opens back up again, just a little bit. Right about there is full. Right there. I don't know if you can see that. Very little change, right? But at any rate, that shows you that, you know, this is following what we've done in the IF. So very interesting. This sounds the best right about there, about 3/4 the way up. So anyways, let's let's go to the other one. That's 5 megahertz is the other time signal. That's very strong. So I don't know if you can see that. That's going to defocus there. It's pretty much closed. So I'll go off frequency. Lots of noise. I have this hooked up to a really large antenna. So this wants to receive lots of stuff at this time of the evening here, and this is this band is pretty active. There is shortwave broadcast in here. This is pretty much between the 80-meter ham band and above. And this is all quiet down in here. Oh, there's some sideband in the 80-meter band. Well, somebody was there a moment ago. And the upper band will be just pretty much quiet at this time. See if we can see my oscillator at 10 megahertz here again. There it is. So that's my own standard here. So there's a little bit of shortwave broadcast there, as you can see at the lower end of the dial at the top here. This comes to life during the day, and this is this here will actually, I'll just bring you back to full brightness here. So this comes to life during the day at the top band here. This is kind of middle to end of the day and in the morning, and then of course this is the beacon band here, which is going to be active most of the time, at least with local beacons. So all in all, let's leave that here. Let's go back down to here and move this up to here. So all in all, like the radio itself is, it's working just absolutely fantastic. Out of most of the radio receivers that I have restored, I honestly have to say the Stromberg Carlson is probably the most enjoyable to use, really. The fidelity control, as you heard, is just makes AM listening fantastic. Now, you can't really use the fidelity control if they're station on station, if they're very close together, because the IF just goes so wide that you're kind of into the next frequency already. So when stations are piling up, you have to have this narrow, and it really does narrow into the frequencies quite well when they're very close together. So that that variable IF width really does help. Tons of audio driving power. It gets quite uncomfortable after that dot. This is the dot right here, and as you can see, I'm kind of raising my voice. After that, it gets absolutely crazy. So those 6L6s are driving the speaker. The difference of having that speaker sitting in this cabinet with the acoustic labyrinth behind it is somewhat amazing. The bass frequencies, the lows that come out of this radio receiver are absolutely astounding. The lows are just, I don't know how to even describe it. I was listening to some country music and just all sorts of different things on the AM band here earlier, just trying to find as much different music programming as I could. And it sounds like FM, really it does. The bass is just rumbles the place. If you have a chance to get one of these radio receivers, if you find one of these Stromberg Carlson 145s, I strongly suggest, if the pricing is right, pick it up and put the time into it to restore it. If you like listening to AM and you like these old radio receivers, this radio is nothing short of fantastic. It really is.
Basic courtesy in marriage.
Yeah. I'm thinking of that either husband or wife, and I'll use the wife because I think it leans that direction most often, where she doesn't feel connected any longer, emotionally, spiritually, maybe even physically. She's drawn into this conversation. Okay, there's some things I need to do. Maybe it's the husband.
There's a better example of how this sounds with the microphone more optimally placed, let's put it that way. The only way to really appreciate the fidelity of this radio receiver is to just sit in front of it. I realize in the last shot the audio is a little bit boomy, but I was trying to get myself and the radio at the same time, but unfortunately there's a lot of room echo in here and everything like that. I just about left out the capacitor of doom. Here it is. This is the capacitor of doom that came out of this radio. So this is the factory device. It is actually shown in their parts list as a little half circle on the side of the chassis, and this is the thing. It's clipped in a little hole here on the bottom of the chassis, so it kind of runs through the side of the chassis, and then they bent this tab up. Original device. So let's see how bad the capacitor of death actually is. So there's a lot of misunderstanding around the function and about the function of this particular device here. So AC line cord decoupling and all sorts of things to do with RF and EMI and all sorts of things. I'll get into the exact description of what these capacitors do. Their functions vary within different devices actually, but you'll see the same kind of setup. Sometimes you'll only see one, sometimes you'll see two, sometimes you won't see any at all. It just depends on the actual device itself that the death capacitor is in. In this case, it's an actual radio receiver, so it's doing multiple things. At any rate, so what happens is this thing ends up failing. So they short, and what they do, one side will short, and if both sides short, it'll take the fuse out. But if one side shorts, what it does is it'll take one side of the line cord and put it directly on the chassis. So that's not a very safe situation, is it? So that'll cause some issues. The new replacements to these capacitors are these ones right here. So this is known as an X1Y2 rated capacitor, and they have all sorts of safety ratings on them. And these are designed to fail in a safe manner. I won't get into the failure points of these capacitors and get too deep into the caps here, but at any rate, this should be replaced with a very safe device. If you're restoring radio receivers that have these caps, it's an absolute must to get rid of these things. You don't leave these behind like the previous people that have gone through this radio receiver. So you definitely don't want anything like this to go bad. So let's take a look at what's actually going on with this thing here. So this can be directly, the scale on this device can be directly converted into ohms. So basically what this is going to do is it's going to look for the resistor that this thing is trying to turn into, okay? So this is a very sensitive device. This thing will go up to 40 billion ohms in the forecast position to really look for any type of leakage, any type of resistance that may be hiding in these capacitors due to just it degrading, moisture ingression, all sorts of different things. Again, a very purpose-driven device. So the first scale is red. That's a really bad scale. And then it starts off at the yellow scale on the second scale, and it works down and it becomes green at about 40 billion ohms. All right, 40 gig ohms if you prefer. So let's see how actual bad this thing is. First of all, you know what? Let's test a new one. Okay, so this is a brand new capacitor here. Okay, so what I'll do is I'll just I can turn this on. It'll read the resistance of my hands as I'm holding these things. So I'll just have it in the test position to begin with. It doesn't really matter. So again, it's a low voltage tester. So, you know, there's no issues here whatsoever, right? So the first scale is red, as you can see. When I'm holding these here, I'll bring it up to the yellow scale. To the top of the yellow scale is about 1 billion ohms. Okay. And then if I short them together, you'll see that that's a dead short. So that's the start of the scale right there. And then anything beyond this is about a meg ohm, and it works its way up to 1 gig ohm. The scale flips and it goes from 1 gig to 40 gig ohms. All right. So I'll put this on here. So there it is. Okay. It's on the test. And as you can see, it's comfortably going up to 40 billion ohms and beyond in the forecast position. The forecast position on this thing is the most sensitive position there is. And again, if I just touch the boots of this very, very lightly, you can see that I'm discharging that cap at 40 billion ohms. So it's reading my body resistance through a vinyl boot. So it's reading the resistance of this boot, of my entire body, and then back to this boot here and the resistance again. Okay, so you can see that just by lightly holding that. So a very sensitive device. Again, it was designed to look for obscure issues. So here is the death cap. Okay, so I'll put the positive lead there. Now don't be confused. You can see a chassis ground symbol. Don't be confused by that. This is an alternating current capacitor, and it really doesn't matter. These capacitors are not electrically polarized. So it's in a shell, and of course it's designed to be across an AC line. So the polarity is flipping around all the time. So let's test these out and see what we get. All right, this should be interesting. Keep that here. I want to make sure the boots don't touch anything. So as you can see, that's pretty bad. So that's going to be just below 20 megohms. So this next light up will be 20 megohms. All right, I'll grab this resistor here just to give you an example. I got a bunch of them put together. These are 20 megohms each, all right? So the 20 megohms should be the next light up here. So very, very bad. So you can read, you would actually be able to read this. It's so bad, you could read that on a standard DMM. Okay. This here goes way beyond a standard DMM. So there you go. So that's 20 megohms right there, right across that one resistor. And we're below 20 megohms with this. So if I was to put this across a DMM, it's going to read very close to, you know, I'd say between 10 and 15 megohms. Okay. So you can see that, you know, this capacitor is really bad. Let's test the other one. So we tested one here. I think it might have been that one. This is the one that we've tested here. So it'll creep up to just below 20 megohms. Okay. And let's test this one here. And this one here is open. Oh, no, it isn't. So this one's on the verge of shorting out. This would have been the side that would have most likely caused very bad issues. You can see this thing? It's in the red scale, and it doesn't know what it's doing. Look at that. So right now, if this was attached to a line cord, it would be inside, it would be shorting out. It's sparking, it would be sparking and doing all sorts of things inside there because it's intermittent. And as you can see, it's intermittent in the red scale. So it's really, really bad. So this would have been the side that caused the issues. So now depending on what side you plug this into the wall, okay, because remember, this is putting low voltage across this, and this is seeing this issue right now. So the line cord that's on this thing isn't polarized, so you can plug it in this way or plug it in this way. So there's a really good chance that you would have put the hot side on this, and that would have been connected to the chassis. And as you can see inside, it's intermittent. It's basically, this would be, you could say, sparking inside right now, or sizzling inside there right now. And I can almost guarantee if this was plugged in, the next time this was plugged in, that would become a dead short. So it would have attached the line cord to the chassis. So how do you like that? That was caught just in time. This other side here seems to be pretty constant. So this one here wasn't doing the same thing. This one here is just showing a fixed resistance. So this is, that other side would have been the extremely dangerous side. So crisis averted there. So just think, somebody had worked on this thing and left this thing in there. And that was on the verge of happening. The chassis of this radio receiver was on the verge of becoming live. And who knows if these would have actually shorted, it would have taken that fuse out, right? That little fuse would have gone away. And that's hard on things. You know, it's hard on the power switch, and it's hard on all sorts of things. So definite crisis averted right there. Big time. At any rate, if you're interested in building one of these things, again, this is on Patreon with all the plans, along with many other of my creations up there. Definitely check it out. If you're enjoying my videos, you can let me know by giving me a big thumbs up and hang around. There'll be many more videos like this coming in the near future. We'll be taking a look at vacuum tube and solid state electronic devices alike. So if you haven't subscribed, now would be a good time to do that as well. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way, and gaining access to many of my personal electronic inventions and designs, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll put the link just below the video's description under the Show More tab, and I'll also pin the link at the top of the comment section. So if you click on the link, it'll take you right there. All right, until next time, take care. Bye for now. Hi everyone, and welcome to another episode of Mr. Carlson's Lab. In this video, we're going to finish off the General Electric communications receiver, and in the end, we're going to see how well it performs. So this should be a lot of fun. So let's get started. All right, let's make this radio receiver receive like crazy. How does that sound? Okay, so I've got the turret tuner out. You're probably saying, Paul, why didn't you show us how you did that? It's so easy. It's ridiculous to get this thing out. That's why. So basically, it's you take this nut off, you take a screw out here, and you take one screw off the back side of the radio, and this whole thing just pops out. That's really how easy it is. It's almost ridiculous. Of course, I had to undo the gear. Right? Can't forget that, but very, very simple. So as you can see, it really just fits in like that. That's it. So on the back side here, one thing that is to be noted is you have to set the depth of the actual turret tuner so that the contacts make contact correctly. If you have it pushed in too far, you know, it's going to put too much pressure on the fingers, and you might actually push a finger down to the chassis. And of course, if it's not, you know, if it's pulled out too far, it won't make contact. So there'll be a little bit of experimentation with that to get all of that right, but that should be very simple. And really, that's all it is. So I'm going to take this outside, you know, blast this off with some compressed air. And this here, I'm just going to clean these contacts with Tarnex. Here's a quick look at before and after. And this is how easy they come clean. Now, if you let the product sit on it for just a short period of time, it's even easier. So what I usually do is I let them sit a little bit wet and then come back in about 5 minutes. And it makes this process that much easier. So this is just immediate. Nothing's been sitting. I'll just give you an idea of how well this product works. Now, this has to be done in a well-ventilated area and everything because it does have the tendency to smell like rotten eggs. But at any rate, you can see how quickly that works. So I'll zoom on in a little bit. Hopefully you can get a closer view of that. So you can kind of see here. Hold on while I move the camera just a touch. Got to be careful because I got some of this stuff on my gloves. I don't want to touch anything. So you can see here how clean that really becomes. So these contacts are great. Absolutely no problem with that. Slight amount of wear on here, but nothing. What you see on the contact, anything that's left, is that's part of the contact. So that's purely conductive right now. It's just some areas are polished and some areas are not. So I'll just keep going with this. As you can see, this one's had a bit of Tarnex sitting on it. Stuff works great for these contacts. So again, the stuff absolutely smells like rotten eggs while you're using it, but the result is pretty good. So obviously follow the directions on the bottle and use all the appropriate precautions. The turret contacts are all cleaned up, and I've also washed them off to get all of the Tarnex off of there. So that's nice and clean now. You don't want to leave any Tarnex on this at all. You should always clean that right off. And I did that, so this is ready for the turret to be reinstalled. Now that that's done, I'm ready to replace these capacitors here. Now, in this section, you'll notice that there's a shield here. All right? And you'll also notice that these are the IF transformers right here. Why is this shield here? Why is this metal shield there? Well, what happens is this section has got so much gain that what happens is the IF section wants to talk to the turret and vice versa. So they want to create an oscillation between the two, and they want to, cause issues, right? So if this oscillates, it'll basically cause the receiver to go deaf and, the eye to close, and it's just basically it's listening to itself, really, because it's just going into oscillation. It's something like taking a microphone on an amplifier and putting the microphone right up to the speaker. You know how you get that squeal? Well, this is happening the same thing, but in much higher frequencies above your hearing in the RF range. So on these Tiny Chief capacitors, you'll notice that there's a yellow band, and that yellow band denotes the outside foil, and that end is attached to a ground lug here. On both of these capacitors, you'll notice that this end of the capacitor goes to a lead-out wire, and that lead-out wire runs here and then down, and then this end of the capacitor on this end also attaches to a lead-out wire. You'll notice that this capacitor is poking through a hole in this shielded box. Now, this is a prime example of how important it is to make sure that you have your capacitors put the correct way in circuit. Reason being is you can look at the outside foil layer on a capacitor like coaxial shielding. So since this end is to ground, the whole outside layer of this is shielded right up to this end of the capacitor. Well, what's right next to this? This IF transformer. And we also have a lead coming off of here as well. You see how close it is to that capacitor, that blue lead right there? Now, if I was to take this capacitor out and reverse it so that this end was the outside foil, what would end up happening is this whole capacitor would couple to this. It would couple to this blue lead, and we would get coupling to this lead. And look, it's running right underneath this coil. So you can see the kind of problems that we can introduce if we don't have this one capacitor, just this one capacitor put in the correct way. Since this yellow band denotes the outside foil, this is ground right up to this point. So this wire that's touching it, or touching the case of this, is completely shielded. So the capacitor itself is not seeing this because this is ground. The other way around, this end would be the outside foil, and it could couple to this. Same with this side here. The same thing's happening. So this is where a lot of receiver repairs go wrong, and you get all sorts of intermittent oscillations and just all sorts of things. You tune through the band, and the eye closes and it just gets quiet and all sorts of things. And it's because of things like this. So whenever you're working on something like this, take note of the actual circuitry design. You can see right here that they are really thinking a little hole in the shield here, and this point here is exposed, right? And it just runs right out. Same with this end over here on this capacitor, a little hole in the shield, and this is the area that's exposed outside of that shield. You can see the green wire running close to this IF transformer, but at this point, the gain isn't as high as it is at this point here because we have another stage of amplification at this point right here. So we have some pretty high amplification. Again, you can see that they haven't shielded it over here where this IF is because there's not a whole lot of IF amplification happening at this point. And this is close to the oscillator and mixer. But over here is where it's very, very important. That's why they've installed this piece of shielding right here. So very important in an application like this, and in any application when you're working on a radio receiver, to get that outside foil end put to the correct end, especially when the outside foil is connected directly to ground. Now, some capacitors like this will say outside foil, and some will actually say ground end. All right, this is just denoted by a yellow band. All right. So I have a small device that will help me locate the outside foil of my new capacitors, because new capacitors aren't marked. They don't mark the outside foil end because they're designed to be sitting on circuit boards. They're not put in point-to-point wiring anymore, right? And when they're sitting on a circuit board, you can put them on top of a ground plane and everything is okay. Much different when you're using a new capacitor that's not marked in old equipment like this, when you have flying leads and things are point-to-point. So just something to take note of if you're working on these radio receivers. I hope that helps you out and solves some of your future issues. Here's a quick example of locating the outside foil on a brand new capacitor. So there's a brand new capacitor, and here is the box that's listening to this capacitor right now. So how this works is it's basically, you can see these LEDs moving back and forth on the bottom. So what it's doing is it's just flipping the capacitor back and forth. So the green LED that's lit indicates this lead is now grounded, that lead is now grounded, this lead is now grounded, and then vice versa. This is the signal lead. Now that's the signal lead. So basically what it's doing is ground signal lead, and it's just flipping it back and forth and listening to the capacitor to help locate the outside foil. It's very simple. The circuit is extremely sensitive inside. So now, if I grab the capacitor and just introduce noise from my body, you'll see how incredibly important it is to put this thing in the right way. Because one direction, it's going to just pin this out. In the next direction, it's going to be no LEDs, basically. So the LED on the bottom with the least amount of LEDs lit on the top indicates the outside foil. So we're not looking for full bars, we're looking for no bars or lower, okay? So I'll grab this right now. I'm just going to grab the capacitor. Look at that. So this side is the outside foil, this side right here. Look at how sensitive that is. Now just think if this was in circuit with that wire running across the outside of this thing. Just little old me, I'm introducing enough noise into this circuit that it's detecting the shielding on this capacitor. All right, so this is the outside foil end. So what I'll do is I'll disconnect this and I'll flip the capacitor around, and then you'll see this act in the opposite direction. Okay, so there it is, flipped around. I'll attach this back up here again and get that out of the way. Look at that. Now this is the outside foil end. Of course, if I touch this, I'm grounding myself out, so. See that? That's how incredibly important it is to put these things in the right way, especially in a circuit like this up here. Right? You can see when I don't touch it, no signals coming in. I'll lift the leads up here so you can see the capacitor. All right, I'll grab the capacitor again. Look at that. So there you have it. That's how incredibly important it is to know the outside foil of your capacitors when you're doing any type of point-to-point circuitry. So if you're interested in building something like this, all the plans are on Patreon. Everything's there. Alignment procedure, the build, printed circuit board plans, everything. Parts list. So you might find that interesting if you're pretty much into doing this stuff like I am. This is a very, very beneficial thing to have, and lots of people have built this and are using these things today. All the paper and foil capacitors have been replaced, and one resistor needed to be replaced, and it was that one right there, a 220k ohm resistor. So I can grab something to point right here. This one here was the only bad one. I tested all the resistors. They're all fine, except for this one right here. So that was replaced with another 220k ohm carbon composition resistor. So it's kind of nice that it was right in the same area. As I desoldered the old capacitors from the ground lug here, I also pulled this one out and changed it out as well. So again, all the mica capacitors are fine, and the ceramic tubular capacitors do not need to be changed. As you can see, the turret is put back in. So the turret tuner assembly is a little bit of a, I wouldn't say challenge. It's a little bit difficult to realign, let's put it that way. So when you remove this and put it back in, you have to get the turret depth correct so that the pressure on those little contact fingers that we cleaned up in here is correct, right? Because when these little contacts, these little teeny contacts come around, what they end up doing is they kind of come up and over, and then they push down on the actual contact, and as it goes past, the contact pops back up. Kind of hard to do this on camera here. So adjusting this screw right here, I guess you could say, is what sets how these contacts sit on those little spring type fingers, those little contact fingers there. So if this is in the wrong position, the turret might stop here, or it might stop here. So it has to stop perfectly in the right position so that the whole line of contact fingers make contact with these in the right spot. There's a turret depth adjustment here, so you can set this closer to the top of the chassis or closer to the bottom of the chassis, and that puts more pressure on those little spring type fingers there, so it'll press them closer to the chassis or not. Luckily, this one here is right at its stop, so it's about as far out as it can go, and there's still quite a bit of spring tension left. I had to do that with this mirror. So I had to get in here and check everything out and make adjustments. Now, I don't know if I'm going to be able to show you this, but I will give it my best shot here. Okay, so I'll just zoom this in and move things around. Give me just a moment to set things up. I'm hoping I'll be able to show you what the little contact fingers look like there. I gotta move the focus over to this area here. This was difficult for me to do. So I set it down to the chassis there. It should be good. Okay, so there you go. You can actually see that wasn't too bad with the camera. So if you look, if I don't move anything, if you look right there, you can see the little contact. So I'm going to grab the adjustment on the front. You see that? See how it slides onto that finger and it's pressing on it? Now you can see that little contact go over, and then now it's back onto this side. Now it has to do that on each side. See how there's a lot of spring tension there. So as I let this come back, you'll see the contacts slide. Now it has to be identical on each side. And you can see the whole row of contacts there. Wish I could get just a touch more light on this. I don't think I can. This is pretty touchy stuff. So let's see if I can get just a touch more light on this for you. There, you can kind of see that little contact right about there. There it is. Okay, so I'll hold that very steady, and you can see how that spring comes down, it pops up. So that is right there. So if I move this over to the next one, you see how it pops into place? And they have to be right in the same spot on each side. So it's basically right in the bend of the contact, which is the maximum spring tension. And it's the same because there's two of them. This is only one row. So there's another row down here, and they all have to be set just right. And that all has to do with this one adjustment screw right here. You slide this back and forth, and that'll move this whole assembly like this. And then, of course, if we move over to the back side here, we have this adjustment right here. You can see that right there. This adjustment right here is what sets the actual depth. So this will actually slide down or slide up towards the top of the chassis, moving this in or out, and that sets the contact pressure. So quite a bit of fiddling there with a mirror and trying to get this one adjustment right here, trying to get that one adjustment screw just right. So you can see how it kind of has one of these kind of locking spring type nuts on the back, and that actually made things pretty easy because it binds up as you're doing this. So you hold this and you move it into the perfect spot, and then you get the screwdriver on here and you cinch it up. So that was a good choice for that. The one thing that I would have done if I was one of the General Electric engineers is I would have put an oval slot on the front of the chassis here, so you could just look through the front of the chassis and see it. All it would take is one punched hole in the front, and they could have even done it in the backside. And you could look through that punched hole in the front of the chassis, and you could align everything right up without having to use a mirror. One simple little modification that they overlooked. So I don't know how they would have overlooked something like that, because it's just, after one single alignment, you're going to be like, why didn't you put a hole there to look through? Anyways, so it all worked out okay. So lots of spring tension, as you saw, and everything is good. So I haven't added any lubrication to any of this stuff yet. I will add some lubrication to this. And now we're pretty much on the top side of the chassis. So here's a better look at the top side of the chassis, and I was very gentle with this. I didn't even worry about a little bit, I don't know if you can still see that here, about a little bit of the rubber staining and things like that. I took a damp rag and I just gently went over the chassis. I didn't want to take any of this numbering off. The chassis is in such good condition and there is no rust on it. I didn't want to, bother the coating at all. So this was even much nicer than the audio amplifier's condition, so I just wanted to leave well alone. So very, very light cleaning on this, and it came up just like this. I figure I'm just going to leave it at this point. Again, I want to preserve things like this, and I want to preserve this on the back. You can see that they've even put a coating. I don't know if you can see that on the camera. They have somewhat of a coating over top of it. You can see it's almost like a lacquer that they've put on top of the numbering to try and protect it. You can see it over here as well. They put it over. This is very common in military stuff as well, in the military equipment of the day. So other than that, it's just in fantastic condition. So I'm just going to leave it like this. So I still have to lubricate the tuning capacitor on the top and things like that. But other than that, it's pretty much ready to try out. So we can see if this thing's even going to do anything. So before I even add that lubrication, I'm pretty excited about this. So I'm going to get that amplifier up here and sit this like so, and then have the amplifier sitting right here. And let's see if the thing receives anything just the way it is. Wouldn't that be something if it did? All right, everything is plugged in. Let's see what this thing is going to do. What do you think is going to happen? So I have it attached to an antenna, and I have it attached to this test speaker. You remember the restoration of that speaker not long ago. And it's into the isolation transformer and current limited variac supply. So very crude setup. I just want to turn this thing on and see if it actually works. So yeah, that moves nice and free. No lubrication yet, nothing. So it'll be even better once that's all done. So again, this is just its very first voyage after all of this is being done. So okay, I'll turn on the isolation transformer and current limited variac supply. And is this thing on? Oh, I see filaments glowing over here. So it is on. And I can't see any. Oh, there's dial lights. Let me see here. If I can get rid of some dial lights. There's some of these lights, and you can actually see the dial light up. Look at that. It's lighting up the dial. What other light can I get rid of here that'll make things a little bit nicer for all of us? Maybe zoom on in just a little bit. So you can see it's lighting up this dial. Okay, so this should be fun. Let's see what this does. Oh yeah, look at that. That's not bad for an incandescent bulb. It's actually lighting it up very well. You see that there and all the different bands. It would have been a little bit nicer if they would have actually put like a little bit of a foil compound between it so it didn't shine into the adjacent bands. But other than that, it's actually not doing too bad. You can see it moving up, creeping up incrementally to the top. So not bad at all. The logging scale isn't lit up though. See, oh, the bulb is out under here. There's a, I don't know if you can see that. Yeah, the bulb is out. This is, I think these are just bayonet style. They are. Give me a second here. Nope, not in that one. Bayonet style, where are you? I have a box of these things right over here. Wasn't thinking that that was going to happen, but here, I'll just grab one out of the box. This box here. Let's see if this will light up. Maybe we can get some light happening in the logging scale. Oh yeah, there we go. So that lights up nice. So pardon me here for a moment. Get this down over here. There it is. So where is the logging scale? There it is. Haha. That looks much better, doesn't it? So you can slide the ball back and get the filament right in line with it. So there, now it has a logging scale. See, hopefully that's a little bit more viewable. So the logging scale is now lit up. I wonder if I actually got rid of a little bit more light here. Maybe you could really see this. So give me 1 second. I'm going to actually flip the lab lights off and let's see how this looks in the dark. Not bad. So you can see the log scale. You can see which band here is lit up. The logging scale is lit. And as we move this, isn't that neat? Isn't that just the neatest? That just looks so great, doesn't it? And that's all with these acting as light pipes. All right, I'm not hearing anything, so let's see here. One of these is going to be volume on the amplifier. Here, let's see. Oh, there we go. So which way is it? Oh, I want to go this way. I'll turn that down.
2TO, the letter B. With no. Yes. I'm a child of that. I can kill my life. I'm lose now.
I think that's a dimmer. So give me a second. Let's see if that changes. I'm going to go flip the dimmer off. We have a light dimmer here. Give me a second. 1 sec. You'll hear it in action. There you go. That's what dimmers sound like in AM radio receivers. So that's a typical triac style dimmer that's dimming lights. So that's with it off. This is with nothing done to it. There's nothing done to this receiver. It's working. This is crazy. The eye is very, very weak. So I have to get another eye tube. And the next one. They are alive. So, let's see. So the WWV should be around here. It's right there. Yeah. So that's a WWV. So it's a little off. It's 5.05. You know, what do you expect? The whole turret's been out and everything, right? So the oscillator is alive on on all of these, which is a lot, which is a really good thing. Zoom in on this for you a little bit. Would have been nice if they would have lit up the pointer. This is 10 up here. Probably hearing my own standard in here. That might actually be the monitor that it's hearing. So the oscillator is alive on each band, it seems here. See if we have any WWV. It's pretty quiet here. Every band is awake. That's pretty close. So 4.5 and 5.5, right? It's almost right on at 5 megs. And there's my standards again in here. Wow. So the whole thing is working. Every band is working. So that means that all the contacts on the turret assembly on the underside are working. So every single one of those fingers that was cleaned on the underside is making contact with its correct little contact under there. So that's a really good sign. So the whole turret assembly and everything's working, and it it looks like this thing is working very well. So all the tubes are lit up. Obviously, if one of them was out, we wouldn't have anything. All right, let's test some tubes. So one of the most important ones here is the oscillator tube. And 64s can be kind of picky, notably in Hammerlands and such. Boy, is that ever stuck in there, that one. Oh. It's coming, but not very easily. This tuning tool I'm using is slipping all over the place. Let's see what else have I got here. Maybe I'll use this thing. Might be a little bit easier. There it is. Oh, General Electric. So as you can see, it's the original GE tube. Okay, so 64. I have to set it up according to the chart here, which is 64. So it's type 2. So let's see where we type 2. And it's at 6.3, which we are already at 6.3. Pardon the bumping of the camera. And 25 is the plate setting. Don't have to be crazy accurate with that. So AEF, D and G. So AEF goes up. AEF goes up, and D and G. Can't see the G, there's no G on the bottom there. It goes down. So let's try it out. See what happens. Plug this in. Let that warm up. You see that getting warm in there? If you can see that, there's a little bit of a glow in there. Cover that up. Maybe you can see that. Can't get too much closer. And so let's see what we have for test. Well, that's mighty fine. No problems with that 64. Okay, so I'll just leave that on the bench. Put that in a moment. So the next one, Set these all back. The center here again. So this next one, I guess we could go for the 6BE6. Let's go to the 6B. So here we go. So we have two tests for the 6BE6 on this tester. So it's number 2, 6.3, and 22. And so that's the first one. So 22. And they're both number 2. And let's see here. So A is top, B and D is bottom for the first test. So A is top, B and D is bottom for the first test. Okay, move that out of the way. Grab this. See how we're doing. It's a nice thing about these IT17s is they're very thorough test. So all these tubes are 6.3 volts and the line has been set. So those are a bunch of things that I neglected to show, but those are just something that's going to get set in the left. So if the line voltage is low, you can move this up or down and it'll move the line so that this is calibrated correctly. If you want a really good tube tester with extended charts, these extended charts are everywhere. The model IT17 is a mighty fine tube tester. No problems there, and the good as well. Okay, so take this thing out again because I don't like moving levers with the tubes in. Okay, so now we have to do the second test. So it's 2, 6.3, 26 is the next one. So say about there. So at least from my eye, that's pointed to 26. So close enough anyways. And so here we are, 6B6 again. So we need to go EFG is up and B and D is down. So EFG is up, EFG is up, and B and D is down. This is very important to have set correctly always, is the filament voltage, but all the filaments in these tubes are 6.3 volts, so it's just, you know, set it and forget it with these tubes, right? All right. No problems. You're probably saying, you know, Paul, you're not checking for shorts and stuff. This is leakage and shorts. If anything was here, this would come on. So whenever these tubes have a short or they're leaky, it's kind of telltale on the meter. So if there's something shorted in there, usually these don't read very good, or the needle will just pin. All right. So if there's any type of a heater short, that'll just show up right away on this. And, you know, the light hasn't glowed, so I'm just confident that everything is fine. Once you start using these testers for a while, you get pretty comfortable with the way that they work and you just expect certain things. So if you're new to it, yeah, you can follow all the leakage and short tests and do all that kind of stuff. And yeah, may as well just plug this one back in while I'm here. And there you go. Okay, so 6, BA6. 6BA6, one test. 2, 6.3, 23. Okay, so 6.2, 23. Say about there. Set these all back to the center again. And let's see here. So 6BA6. A, B, E, F. A, B, E, F, D, and G. Okay, so we have 2 of these. And there's only one test for each, which is kind of nice. There we go. Now these I would be very concerned about because this is the IF amplification chain, so these are very important. So if these are weak, then of course the receiver won't work up to par. So if the detector, this little detector tube is weak, it'll affect the performance of the receiver. Not incredibly much. The oscillator mixer and IF chain is extremely important. Of course, so would the RF amp over here too. So let's test this one. Oh ho! Look at that, eh? Questionable. So it's in the question mark area. It is coming up. We are at 23, right? Let's make sure that all the settings are right. A, B, E, F, A, B, F, D, and G, yep. And it is number 2. So, there we go. Questionable. So this one here will get replaced. We want a super strong IF chain. Because remember, we want to make this thing perform just the way it did when it rolled off the factory floor. So that's the second IF amplifier tube there. See what happens with this one. For those of you wondering, these aren't transistors. If you're new to this stuff, these things have to warm up. That's the reason I'm just sitting here waiting for it to warm up. Okay, let's see what this one's like. Oh, no problems with that one. So this one is okay. That first one is a little bit tired. I want to get rid of that one. So I can test the little 6AL5 here. And I'll test the other amplifier. So let's go 6A L5. Six AL5. Okay, 1, 6.3, 22. It's about there, close enough. B, D, and E. So there's 2 tests for that one. So B, D, and E. Okay. So this is the, if this was weak, it wouldn't demodulate very well. And it would also, or I shouldn't say demodulate, it wouldn't detect very well. And it, the AVC action or AGC action wouldn't be very good as either, so it wouldn't have very good, look at this. Already we have a problem. So we got a bunch of tubes in this that is short, showing short too. So usually that's filament. It is leaky. Oh no, it's going down. It's still questionable. If it does that even once, I don't want it in there. Test somewhat good. Okay, so let's test the other portion of it. So the reason, if it's humming like, or if it has a heater to cathode short, which this indicates here, that could introduce hum into the audio, and we don't want that. So it's G, A, and D for the second one. So unplug this. Go G, A, and D. The second one, okay, and I'll put this back in. I usually always leave it on the leakage setting. That way, that's very sensitive, right? You can see it, the short went away, but the leakage was still there on the last one. So one portion of it, that's really strong, that one half of it. So there's 2 diodes in here, right? So this is testing each diode individually. So this one's getting replaced as well. Okay, so we have 2 tubes that are going to get replaced so far. And let's take the RF amplifier out. Wow, that 6BC5 was tough to get out of that shield again. Okay, so I've got it out now. So it needs to be set to number 2 over here. 6.3, 22, 22 there. AEF, AEF, and BG, BG, and C. All right, let's see what happens. These are great RF amplifier tubes, really large cathode area. They work very, very well. If you ever want to build a vacuum tube RF amplifier, use one of these tubes. 6BC5, 6CB6, 6CW6, all those are really great tubes to use for RF amplifiers. 6BA6 works good too. You find them in a lot of the pre-selectors and things like that, but these are just fantastic. Okay, so nothing there. Whoa, that one's really strong. Good RF amplifier tube, that one. No problems with that. So we need 2 tubes, 6BA6 and a 6AL5. So I'll get that in here. We'll get going on the RF alignment. I'm ready to perform the IF alignment, and it really is quite simple. So I'm feeding 455 kilohertz through a small blocking capacitor into this portion of the tuning condenser right here. And if we listen to the speaker, this up here, that's what it sounds like. So the signal is going through 10 picofarads, so it's very lightly coupled, and the signal generator output is 1 millivolt, so it's very small. So now you'll see what happens here. You see the VTVM? See how low that is? Well, the speaker looks like a dead short across that right now, so if I remove this, you can see how much more I get there. So it makes the VTVM much easier to read, so I'll turn it up just a touch more. Now this isn't loud enough to hurt the audio transformer. See, it's as loud as it is. Right, and as you can see how it affects the VTVM, right? Because it has to drive the speaker. Well, we want it to drive the VTVM comfortably. So that low level audio will not hurt the audio amplifier at all if there's no load across it. So now what I want to do is I just want to see how close this thing actually is. So what I'll do is I'll just tune the top slugs of these IF transformers first. And what we're doing is we're looking for a peak right here. So we'll see if we can get a peak out of this. So here we go. See, it's coming down now. So if I back this up here, you can see it comes to a peak and then I pass it. And I gotta say, that one's pretty close. That's spot on. So put this one in here. Okay, so keep an eye on this. So the IF chain is very close. In fact, I don't even think this has been tampered with. It looks very original. It's right at the peak. So I'll move this one a little bit. See, it comes down, and I'll move it back to the center again, and it comes down on the other side. So what this is telling me is chances are this entire IF chain is in tune. So now what I need to do is there's also adjustments on the bottom side of these IF transformers. I'm going to do the same thing on the bottom. I'll just put this in on the bottom and see if I can get more of a peak out of this, but I really don't think I'm going to. I think this IF chain is perfectly in alignment. All right, here we are on the bottom side. Let's try this out here. Yeah, they're peaked. There's no problems there. Let's go to this other one here. And we'll try this one right up here. Yep, they're peaked up. No problems with the IF chain. They were spot on. Even changing the tube in the IF there didn't affect it at all. So no problems right there in the IF chain. That is spot on. All right, let's adjust up the broadcast band. So the first thing we need to do is adjust the dial at 580. So we need to set the dial tracking on this radio receiver correctly. So the signal generator is set to 580, and I'm just putting signal into the antenna jacks. So we have to adjust this one here for 580, and we have to adjust this one here for 1500 or 1.5 megahertz. So let's see where we're at. So let's move the focus here, pardon the camera movement. Okay, so So right now this is at 600. Get that out of the way. It's close. But that's actually 580. So I don't know if you can hear that. So that's where 580 actually is. But it's supposed to be here. So we set it right to where it's supposed to be. Actually, 580 is supposed to be straight on, is right there. I don't know if you can see that. It looks off when you set it on an angle. I'm looking straight at this. So 580 is about right there. So now, in order to make that 580, I have to adjust this on the top right here. So what I'll do is I will adjust this. That's about the center right there. So now the dial is at 580. Right there. So if you look at it straight on, it's kind of hard to get this straight on. See that? Right between 560 and 600. All right. If you just look at it on a bit of an angle, it looks like it's off. So it's kind of hard to see. You'll have to just trust me on this. So now what we need to do is set the signal generator to 1500. And that should be right about there. Okay, so I'll just set the signal generator to 1500 or 1.5 megahertz. 1.5 megahertz. Turn this up. Wow, and that's close. Wow, that's spot on up there. Well, I'll show you what I need to adjust anyways in order if that was off. So I have to adjust this one right down in here. So I'll just put this in here. So you can turn that right off frequency. So that's where it is. So it's right at 1500. Now, to adjust up the sensitivity, we can just use the eye. So we don't even need a VTVM or anything. We can just use the eye to set that up. And really what that is at the top end of the band, right at 1500 right here, what we do is we set the RF amplifier, which is right there. I don't know if you can see that. It's the RF amplifier adjustment and the antenna adjustment just for a peak signal. That's it. So all we're doing is we're adjusting those up. So I might even be able to hear the difference. Or maybe not. See if I can do this and show you the eye on the camera here. So keep an eye on the eye. See that small amount of movement there? Turn it up a bit. And that adjustment here again, slipping out of the thing there. So watch the eye. See it's opening. And that's right where we want it, at maximum sensitivity. And that's just by tuning this one back and forth. And then over here, we have the antenna section, which is the same idea. See how we passed it? That's maximum sensitivity. And I passed it again. That's maximum sensitivity right there. And that's it for the AM broadcast band. It's tuned. That's how easy it is to tune these things. So I'll just turn that down so we don't have to listen to that tone. So now I need to do that with all the other bands. Exact same thing. The other bands do not involve this one adjustment here. It's just these three. So we just adjust the band accuracy with 1, and then we peak up the RF section with this one, and then we peak up the antenna with this one. So in the actual alignment instructions, they tell you to peak the whole thing up with your signal generator, and then in the very end, they want you to peak the antenna section to your own antenna. So they're actually telling you to sensitize the receiver to the antenna that you're using. So peak up this last one here attached to the antenna. And of course, when we're actually listening to this, this will be attached to the 369 antenna. So this will be peaked up to that antenna right there. And that's pretty much it. So now what I need to do is I need to just go through all the rest of the dial, through all the different bands here, and adjust all of those. And once that's done, we'll take a listen to the radio receiver and see how it sounds. Check out these before and after shots of these knobs here. Look at that. Look at this. It's just disgusting. So it's an interesting kind of plastic. As you move it around, it has kind of this greenish yellow color to it. It's kind of neat. But in normal light, if you're looking at it, it's kind of a silvery, just a bright shiny silver. Now I haven't polished this at all. This is just cleaned. So I haven't put any plastic polish on this thing at all. So from this to this. And here are all of the parts that have been replaced in this radio receiver. Now that's excluding the large filter cans because they're still in there, so there's quite a few capacitors and things that are, you know, still left in there as just for looks, I guess you could say, kind of like dummy capacitors. Just to make it look original, so that's not in this pile either. And of course, you know, the stuff that's fallen on the floor and gone in the garbage in the meanwhile also isn't in this pile, so this is kind of the bulk of it right here. So quite a few parts and pieces were replaced to make this radio receiver come back to life again. The radio is warmed up, and let's see how well it performs. So I'm way behind the microphone here, so I'm going to sound off in the distance as I'm talking because the microphone is focused right on this radio's speaker, so we can get the best idea of how good this radio really sounds. So let's start off and take a listen. Oh, by the way, I'm on the broadcast band, and of course the logging scale is completely lit. It's just the lighting in here. Here, I'll give you an example of this. So that's with 2 filters on. You can see the band is lit here, and then this band is lit here. So this is more of how it looks to my eye, but of course the camera is more sensitive, so it's kind of lighting everything up. All right, so we'll go back to the brightest setting. All right, so let's take a listen. I'll turn the volume up.
Think in terms of controlling boards like they do. Now there's fury as the beating of a drum.
People behind that, but these are real kids that you and I know.
Very basic way you can help. Still, but the beating grows louder. I refrained and stood still, but the beating.
And trying to get to the highway westbound.
Higher society from the bottom. Into it.
I was nervous all That's the start of what could be a war.
And again, are you okay? 50s. I remember $20
an hour. Of the 13th Amendment to
for an organic chemistry test. I run a
49% of women, 49% of men are fans of the Dodgers.
Fire was put out fairly quickly.
Junior Ryder, 7:45 East. Field empathy.
Hours in participating restaurants make cheese in central Alberta. I think in the court.
All coming to Vancouver for one show at the Commodore Ballroom. So no matter where you are in Canada,
Place the board.
78148
Well, whoever you may be, whatever you may have done, how far you may feel you are away from God, God loves you. He sent his...
Pretty amazing sound for this old radio, eh? Wow. And there's so many stations in there. This thing is receiving very, very well. Very hot receiver. This thing is working just top notch. Wow. All right, so let's try some other bands. Because of the time of the evening here, a lot of the bands are not active. So what I'll do is I'll just give you a quick run through of the bands, and you can hear the sensitivity. There's a lot of static there, so it is trying to receive. But this next band up, there pretty much won't be anything there. Just a bunch of, computer-generated noise. So let's take a listen. I'll darken this up so you can see the band change. Okay. The WWE should be there. Here. There it is. Interesting. Something was sweeping across that frequency. Station there.
Right.
Something there.
That's as good as Grad's provision as putting overdive.
Another station there. Just so you know, this is as smooth as glass. So I spent a bit of time cleaning the little bearings up and everything like that. And this is, it's just, look at that. It really does feel as smooth as glass. Anyways. I'm reaching from way behind the camera here. And you'll see me rest my hand on here because my arm's getting tired because I have my arm fully extended as I'm tuning this thing here. So I'm way behind the tripod. So pardon any bumping of the tripod as well. Somebody there.
Lake fences where cows are on turnips. He says there's a lot of snow in the mountains behind the farm, but none has yet fallen on the flats. After a fair amount of rain last week in North Canterbury, this week's icy mornings and sunny days have been...
That is definitely far away. Hey, David Tipton, if you're listening,
and dry rates are quite high.
Do you recognize this?
20% on some farms. A good result would be under 5%. A Pyramid Valley farmer reckons it could be due to a lot of dead matter found in longer pastures that the sheep are eating. Apart from that, winter farming is going...
So I think that's from Australia, I believe. Could be wrong, but it sounded like that. That's quite a ways from here.
Lord have mercy! Aren't this the door of
Alright, we're going to try another band here as well. So you heard me calling out to David Tipton there. He's another radio restoration fella here on YouTube. If you haven't checked out his channel, I strongly suggest you check out his channel as well. He does some really fantastic restorations. David Tipton is his name. I hope I'm pronouncing that correctly. Sorry, Dave, if I'm not. All right, so let's try another band here. See if anything's on here. WWV, rated 10 megahertz there.
Pereira e Dom Phillips desapareceram no dia 5 de junho no Vale do Javari, no Amazonas. Eles tinham saído da comunidade São Rafael rumo à Atalaia do Norte. A viagem...
Probably very far away. There you go. So you can pretty comfortably say that this thing is receiving signals from all over the world, and quite nicely as well. WWV, 15 megahertz. We'll hear it beep in just a moment. There it is. Boy, this radio is really showing off today. It's, at least hearing one distant station on every portion of the band spread here. It's doing pretty good. Pretty impressive. This is getting pretty high in frequency for this time of the evening here, so I'm not too sure if we're going to hear anything here. Maybe just computer-generated noise and stuff. This radio receiver is really showing off for all of you. And there you have it. And the next one here, these are just basically a whole bunch of condensed bands. So this is more of a band spread kind of setup until we get right up to here. And then this goes from, 3.1 megahertz in the next band. Well, I'll click to it. So from 3.1 megahertz all the way over to 8.4. So basically it's a whole bunch of V's all in one band if you just want to cruise quickly through it. And then the next one goes from 7.5 all the way up to 21.75 up here, right? So go up to that one there, right? Let's take a listen here. Quick example. WWD 10 megacycles.
要不撇下我们，不丢弃我们，使我们的。
威胁着人民群众的财产安全，通信部已经。
各种的验证这个短信，然后我们也推出了这种短信炸弹。
So you get the idea. The radio receiver performs like crazy. So the way that this thing performs right now at this time of night, and as you can hear as I'm sweeping through the bands, there really is no dead spots. Like you don't really hear it go right quiet and then come back up again. They did a really good job designing the coils in this radio receiver. And it's just, yeah, it's a fantastic receiver. If you ever have a chance to get one of these things and you're an avid shortwave listener like I am, it is a lot of fun cruising around the bands and looking for those stations. I would strongly suggest this radio receiver. It for a consumer grade radio receiver that's on the verge of trying to be like a communications style radio receiver, this thing is really, really doing well. Fantastic radio receiver. I'm extremely impressed with this, and I'm really looking forward to scanning the bands and looking for all of those distant stations here. So this will definitely receive a special spot, and I will be using this thing quite often. If you enjoyed this video, you can let me know by giving me a big thumbs up and hang around. There'll be many more videos like this coming in the near future. I have many different types of restorations coming, solid state and vacuum tube. Many of you know that we're in a communications receiver restoration series right now, but I assure you I'm going to sprinkle in lots of other restorations in between. In fact, I've got a few of them waiting right now. So if you haven't subscribed, now would be a good time to do that as well. And if you want to be notified as soon as I post my new videos, don't forget to tap that bell symbol. This way, as soon as I publish a video, you'll get notified right away. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way, and gaining access to many of my personal electronic inventions and designs, like you've seen in this video here, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll put the link just below the video's Show More tab, so that's just below the video's description, and I'll also pin the link at the top of the comment section. So if you click on the link, it'll take you right there. You can check it out. All right, until next time, take care. Bye for now. Hi everyone. In this video, I'm going to electrically restore this radio receiver that used to fly around in a Boeing B-17 in World War II. Very neat receiver. And then, once this is electrically restored, at the end of the video, we'll take a listen to it and see how well it performs. Should be a lot of fun. I previously, in a previous video, built this power supply for this radio receiver here and showed the entire process of that as well. So this is this exact box that this is right here, and it started out just like this. I took the wrap off it, and this is how it ended up right here, right down to the wrinkle coat finish. So if you're interested in seeing how this power supply got built, you can check that out. It's in my videos list as well. So that was a lot of fun. So the reason that I built this external power supply for this radio receiver here is way back when these things were on the planes have a 24-volt supply on them. And this thing had a thing called a dynamotor inside, and that dynamotor sat right in here on the upper side of the chassis. That dynamotor makes a lot of noise because basically it's the old version of a modern inverter. So you know how you go out and you say buy an inverter for your car that plugs into the lighter socket, it takes 12 volts and say steps it up to 120 so you can run appliances in your vehicle, right? Well, a dynamotor does the same thing, except it's a motor on one end, and on the other end, it's a generator, so or dynamo if you like. And what happens is that thing makes a lot of noise in these older radio receivers, even with the case on. And pretty much everybody that got their hands on these things removed them and put a power supply in the radio itself. And this one here is no exception. This one here has a power supply. So the reason I built an external one is the power supply that's in this radio here doesn't really have the correct voltages, and there's a whole bunch of things amiss with that. So I'm just going to remove that power supply out of here and use this external one. In fact, I think this looks much nicer anyways, and it matches the wrinkle coat of the radio receiver. So that, all with an umbilical cord that runs over to this, should turn out to be very, very nice. Now this will be a very accurate representation of the way this radio receiver worked way back when, because this puts out pretty much the exact voltages that this radio requires, whereas the person that put the power supply in here the first time, the voltages were all a little bit low, so the performance may have been degraded just a little bit. So this is going to be a great video. There's going to be a lot of hints and tips in this video regarding restorations and what needs to be changed in radio receivers like this, or pretty much any communications radio receiver. So join me in this adventure, and I'll share all my restoration knowledge regarding these radio receivers with you. Let's get started. The first thing that I'm going to do is remove the power supply that the previous owner had put in this. So you can see the power supply right here. It's got two big transformers, and it's on a little bit of a chassis. So I can take this out here, and that'll clean up that area, and it'll also give me a couple of transformers for my junk bin again, so I can use them for something else in the future. They look like they're in relatively nice condition. So I'm going to get rid of that, and that's going to leave a large hole here in the chassis. That's where the dynamotor used to sit. What I'm going to do in the future is I'm going to design a product detector for this radio receiver. What a product detector does is basically it just makes sideband much easier to listen to. So I'm going to design a circuit specifically for this radio, and I'm going to also make a universal product detector for many other radio receivers, and I will share that design with you here on this channel. So if you haven't subscribed, now would be a good time to do that, and that way I can cram your head full of knowledge. So I'll share all the design thoughts and everything with you as well as I'm doing that. So it should be a lot of fun. I've got many, many other communications receivers that I'm going to go through. So for those of you that have been on this channel, you know how many old receivers I have. So it would be nice to make a universal product detector. So what I'm going to do first of all is I'm going to remove this umbilical cord that I added to this thing, quite some time ago now. And I'm just going to clip the wires out, and I'll leave just a little bit of the tailings on here. And that way, when I go about attaching this cord again, I know exactly where the wires came from, and I really don't even have to think about it. I'm also going to rewire the switch on the front here. This switch originally switched the 24 volt supply to this radio receiver. Kind of odd the way they did this. I don't really agree with this, but you know, they had MVC, right, manual voltage control or manual volume control in some cases, off, and then automatic voltage control or automatic volume control. It can be used as either or. So in this case, this particular radio here, the off is in the center. So what it does is when you're on this side, everything turns on and it goes off, on. So it kind of gets this off, on jolt every time you want to go from manual to automatic on each side here. So kind of strange, but I would have probably had AVC, MVC, and then off. If I was to design this, it would just make more sense. I don't know why they had off in the center. So they must have had some strange idea for that there, but it just doesn't make sense to, you know, jolt the system all the time as you're going off and on, right? Back and forth, just introducing more issues. So what I'm going to do is I'm going to get rid of this here. So what I'll do is I will desolder. I'll get close to this here so you can see what I am doing. Yeah, AVC and MVC. AVC, again, a lot of the times, depending on the radio manufacturer, it can stand for automatic volume control or it can stand for automatic voltage control. So just depending on who is actually, you know, doing that, what radio receiver or the company that's actually doing that. So that's that wire there. So we know that this one here is going to go to the negative of the power supply. I've trimmed this one off. So we know that this one is the positive of the power supply. It's caught here in the wrapping. And what else have we got here? We got the line cord. I don't know if you can see this. Hopefully you can. I'll get you a little closer to this. Right down in here. So I'll just get rid of the line cord. I've got my soldering iron set to blazing hot for this. So these tabs on the older transformers and things like this, they sink off a lot of heat from the soldering iron tip. So, you know, dwell time is definitely a thing. So, and this here looks to be a ground. So I'll get rid of the ground with this screwdriver here. I'm probably gonna have to cut this off anyways, but this is ugly. Somebody's put one of these kind of crimp tabs on here. So it's ugly. I'll replace that later on. And this is the line cord. Oh, that was a line from the transformer. That doesn't really matter because the whole thing's coming out anyways. This is the other portion of the line cord right here. You can see that. There it is, just kind of tacked into place. This block is going to come off as well. There was a factory connector that plugged into this, and with all of these receivers, it's basically missing. Now, I don't want to tie the power supply with the new, this one here has a new umbilical cord right here that's going to run, I'll just back this out so you can see this, new umbilical cord that's going to run to the power supply. So this plugs into the power supply, and then this will be fastened in here to the radio receiver. I don't need this here with these pins open like this, right? Because there's going to be a lot of different voltages apparent on this or present on this, and you know, there's a hole in the back, right? So, you know, I want to keep this as safe as possible. So this will just go missing, and I'll put all of these connections on a terminal tie strip in here, and then this new cable, which will get a covering too to make it look more era specific. I'll put a cover on this. Will run in here and just be tightened down to the chassis. So there's a lot of mods that have to be done to this thing. But in the end, you know what I'm going to do? I'll just cut this. Actually, is this going to slide out at will? So I'll just cut these off because this is going to get cut here. And that comes out. So I have a spare computer cord, it looks like. And these have a higher impedance audio transformer, so they're, you know, designed to, you know, drive headsets and things like that, right? So I'll probably end up on that same chassis here that I'm going to put the product detector on in the future. I may even put just a standard audio transformer in here, so this will drive an 8-ohm speaker. I'll leave the factory audio transformer in here so it looks all factory. But, you know, again, this isn't going to be a shelf queen, right? I'm going to use this thing. I want to use this for, you know, for communications. So I like doing AM on 80 meters or 75 meters if you like. I like doing that a lot. And this will probably be one of the radio receivers that I do that with. And I like listening in on sideband as well. Of course, I do sideband as well, but AM is my preferred mode. I like AM. You can also check out my refurbished broadcast transmitter that came out of a radio station. If you look in my videos list, there's another neat video that you may not have seen. I stand inside my broadcast transmitter. That's how big it is. So I'm actually right in the process right now of moving it here. So I've got pieces of that broadcast transmitter actually just outside the frame here. So eventually that case will come here, and I will get back on 80 meters AM again. I know many of you have been asking me about that. You've been saying you'd like to make contacts with me on 80 meters, and I will. In fact, I'll probably make an announcement when I'm going to get on the air. And all of you that want to make contacts with me on 80 meter or just listen in 75 meters, you can do so. So hopefully this is going to do it. Hopefully I got all the wires out of here. Looks like there's 2 screws holding this down. One here and one over in the corner here. Maybe we can lift this big chassis out. That'll leave a nice big hole here in the chassis. And I can put another plate on here and put some... Will it come out? Have I got everything off? That came out too easy. That was just way too easy. So I got 2 spare transformers now. So I talked about this in a previous video. This is kind of confusing. It's basically 2 power transformers in here. So it really only needs 1 and a vacuum tube and a filter. But yeah, that's what happens. So this here is the area. Look at that big hole in the chassis now. So I can put another solid piece on top of here. I have a bunch of Hammond project boxes that would probably, one of the bottoms would probably be very close to this. And I can just put that on here and that'll fill up this hole, make a nice cap for it, put a tube socket, maybe a transformer on here for the product detector. I think that'll work out real slick. So what I'm going to do now is flip this thing back over again and start removing this thing right here. I'll take you through that process. And after that, we'll start getting into the caps and the components, and I'll start talking about why I need to replace these capacitors. And I've never actually tested one of these fast capacitors on my channel before. So this will be very interesting for both me and you to see if these things are leaky. They're completely sealed, and a neat capacitor, you know, very neat, you know, soldered on the ends and stuff like that, sealed tight. So let's check out and see how bad these things leak, if they even do. So that'll be next. There's a whole bunch of connections on the back side of this block here, so chances are I'm gonna have to bridge some wires. They've got connections here, there, and everywhere. You can even see they've got ground tabs. You can see there's wires or capacitors attached actually to this little eyelet here. So there's going to be some modifications to do there. Let's see how this is attached. Does this whole thing come off? I think it probably does. It would need to be pretty sturdy. You know, these things are, look at the size of that, eh? These things are put together very quickly, and of course they need to be serviced in the field. So that is definitely sturdy. 2 big screws that go right through into the chassis and 2 down here. So that would definitely not break. So all of these connections here, you can see there's certain connections that are bridged together, and I'll just zoom on in. Hopefully you can see that okay. So there's somebody's actually added a bridge wire back here. And all of these have to be desoldered and of course put on a terminal tie strip. And looks like these are probably decoupling caps. There's a decoupling cap here and one here and another decoupling cap right up here which runs to the fuse. So all of those caps will most likely need to be replaced. They are sealed. Again, we'll test these and see how well they've done over the years. So what I'm going to do now is I'll just desolder these wires back here, and I'm going to most likely have to fit a terminal tie strip in here somewhere and move these from this to a terminal tie strip, which is much further back in the chassis. And I'll use one of these screws, probably with some form of an eyelet, maybe a rubber grommet, to hold the wire that's going to run out of the case here that runs off to the power supply. So I'll get some parts and pieces ready here and move these over. All right, I've got my box of terminal tie strips here, and that was sitting right on top. So I'm thinking I can probably use a screw down here to fit one of these. I don't know if there's enough connections there. Somebody's already used this one. So you're looking for stuff like this. Ham radio swap meets are a great place for stuff like this. Usually this stuff sits on tables. So if you're getting into point-to-point wiring, I think this one might actually be a better choice. Look at all the tabs on that one. That's got 6 tabs with a ground in the center, making 7 total. So yeah, I'm thinking that's going to probably do that, because there's 8 leads on this, right? So I can probably tie most of them off here, and that way, if say in the future it was ever desirable to put this thing back in, which I don't think it ever will be, because it's going to have that pre-made power supply for this thing, but it leaves the option of, you know, just removing this and tying them directly to the pin again. I always like to make things very easily reversible. So if, yeah, again, you know, if this was ever to go to somebody down the road and somebody's like, I'd really like to have this connector back in here, I'll hold on to this connector, and it will always be in an area where I know where it is. So if I was to ever get rid of this receiver down the road, this would go with it if somebody ever wanted to reattach this. Again, I really don't see the reason with that nice, you know, custom built power supply for this, but you never know, right? So this will most likely go here. So what I'll do is grab another screwdriver that's going to fit in that smaller area. You can see this here. Here's another screw. I'll zoom you in a little bit. Another screw down here. And that's to one of these decoupling or bypass capacitors, if you'd like to call it that. So this goes down in here and it's holding on to something else, so that'll definitely have to go back in. And then I think that would work out really nice right there, wouldn't it? Look at that. Nice terminal tie strip right across here. Well, look at that. It's meant to be. So it'll go right in there, like so. And then the umbilical cord will run here, and I'll put a grommet here, and it'll be tightened in, and all the wires can go right to here. Isn't that nice? Okay, so now what I need to do is remove all of these wires and attach them to this strip. And I also am going to need to remove this capacitor here, and this will need to get replaced most likely as well. Again, we'll test these here in just a minute and see which ones need to be replaced. They're all over the place in here, so I don't have a whole lot of faith in these things. These have been in this radio since the 40s, right? So get that on there, huh? That should be fun to test. So let's see here. That'll be a good replacement. Probably something like that. So leave those there. This out of the way. And I'll show you what I'm doing here. So I'll put a new tab here. Much easier to work with a new tab. So let's see if this will thread into here. A little tight it looks like. Let's see if I can get that started. You see that there. So that looks like it should work. Of course, it's going to be difficult, right, and catch under that corner, right? What else is new? Give that a bit of a bend. Put that right there like so. And then this will go back in here, and this gives me a new place to tie the, just like so. Gives you a new place to tie the new bypass cap if it's going to be replaced. So again, we'll end up testing this here in just a moment. I'm imagining that probably most all of these are toast, but so I'll probably vacuum this out too. So that's all prepared. Now that that's there, that's like so. I can put this down here. So yeah, I would imagine I'm gonna probably end up desoldering all of these wires first. I might be able to mount that right now so you can see that. It looks pretty good. The previous connector is now completely removed, and the wires have been moved from here to this terminal tie strip right here. So what I've done is I've made a legend here. So if this was ever desired to be put back in down the road by somebody else, you can see they're numbered 1, 2, 3, 4, and then so on the other side. These numbers correlate to that. So the wires that have been soldered in here would attach to those pins. Just to make things easier, whenever I'm done with something like this, I always create a booklet, put that information in there. So if somebody does get this down the road, and again, if it was desired to, put this back in, it could very easily be done. Again, I don't see why you would want to, but you never know. I'll also get rid of all of this stuff here because that just adds to confusion. This was written in here when I got it. These wires here would run normally to the B+. So you can see that this is heat shrunk and there's a piece of wire that runs off of this. So what I'll do is I'll put a standoff here and solder these to here, and that'll get rid of this wire here and clean this up. You can see these wires here are for the filament modification, and so this was done again by the previous owner. And you can see that they've got looks to be a nut in here and a whole bunch of wires that are probably on eyelets or something, squished together in there. So these all go over basically to a connection on the tube socket here. So what I can do is run these to the tube socket and really clean all of this up, get rid of this. Again, I really don't need this big chunk of heat shrink in here. So that'll clean that all up. Now I left a lot of umbilical cord here. So I've got lots of cord because I planned on cutting this quite a bit shorter, and basically it'll be down to here or so, I would say, right? So what I'll do, the reason that I left so much wiring here is because these brown wires in the harness will run up to this switch up here. This switch the power to the radio receiver on and off. So the dynamotor, this would turn the dynamotor on and off, this switch. That is the AVC, MVC, and off switch right here on the front of the radio. So I'd planned on shortening this up. So I need to run the AC lines up to this switch here. So this will be fastened here, and it'll give me a lot of extra that I can run the lines up and make that a nice clean install. The red lead will also go over to this area right here. So it's always a good idea. I didn't know when I was building this, how much I would, aside from the AC lines, how much the other leads would run into the chassis. So I just left them all very long. So there is a bit of wire waste, but that, you know, the lengths of wire can be put into my bin and I'll use them for other projects down the road. So really nothing is wasted. Let's test one of these fast branded capacitors and see what condition it's in. This one's rated at 0.01 microfarad at 400 volts. So this is one of the caps that was on that input connector here. It was one of those bypass caps. So as for physical condition, it's in great condition. So the seal on the end is still soft. So whatever material they've used for that seal is very, very soft still. There's no physical leakage. So chances are what's inside this can has been held tight from atmosphere since the 40s. Looks like there is, you know, some resin splatter on the end. That's common, but other than that, it's, you know, very soft seal there. So what do you think? Do you think this is going to test good, or do you think it's going to test bad electrically? So let's see if it's going to leak electrically. We know it's not physically leaking, but let's see what it's going to do electrically. So I'll attach this to the tester, like so. All right. So now this is on forecast. I'll move this to the paper and poly position. So the tester is off. Right now this is discharge. So obviously this isn't charged up, but this is the discharge and on position. It does two things at the same time. Now when I move this to the upper position, that's going to put this capacitor under test. This scale will start out red and it'll count down through the megohms, and then it'll go up into the gigohms, and then that'll be the yellow scale. And then if it goes through that and this turns green like it is right now, we know that this capacitor is good. If it hangs up anywhere in the scale, we know that chances are this capacitor is bad news. So here we go. And as you can see, it's hanging up in the red scale. So this is 0.01 microfarad. This should have gone zip, zip through the scale, and it should have been green really quickly. So now, if I move this to the forecast position, we can get a good idea if this is degrading inside right now. If it counts towards the bad end of the scale, so if this starts to go backwards, we definitely know that this capacitor is going bad. So here we go. I'll move this to the forecast, which is the center position. Watch the LED here. And look at it, counted towards the bad end. So we definitely know that this capacitor is going away inside. So what I'll do is I'll test a good cap. So this is a modern cap here. Same value, 0.01 microfarad. So I'll put this into the test leads here, just like the other one. Now I'll move this back to the paper and poly position, so it'll give it the same test we did first here. So it's off. This is discharge. Now watch what happens here when I test this capacitor. See how quickly that went green? So that's the difference between a good cap and that other cap. Now, of course, if I move this into the forecast position, that'll just stay green. That's not going to count back up the scale whatsoever. In fact, these caps are so good, it'll actually count down through the whole thing and test it in the forecast position. So I'll just move this to discharge for a second. So that's discharged. Now I'll test it in the forecast position, and you'll see how low the leakage is on this. Look at that. It's actually fully testing this thing in the forecast. So that definitely tells us that these capacitors here are on their way out. We could test another one for a sanity test here just to make sure. So sanity check, make sure that we're definitely testing things okay. What I'll do is I will desolder this capacitor here from this terminal, move this lead out of the way, and I'll be right back and we'll test this one right here. I've got this end of the capacitor desoldered right now, so that runs to this other end of this fast cap. So let's attach the tester and see what we have. So this one's rated 0.25 microfarad at 100 volts, so this will count down a little bit slower. But let's see what happens here. So we'll put that in the paper and poly position, and here we go. That's definitely slowing up. So now, as it transitions, I want to see if it'll count back up. So here we go, if it does transition anymore. There we go, so I'll put it back, yeah, see onto the forecast position, it went back up. So, put it back to test, and then to forecast. As you can see, it's going back up again, so definitely leaking as well. So we can tell that, you know, all of these caps in here are on their way out for sure. So all of them have to go, and there are a lot. So I am going to be desoldering caps for a long time. So I'll just grab something to point with here. I'll zoom on in a little more. So there's a cap here, this cap here, which is easy to see. There's a cap here, a cap here, there's a cap here, one here, there's another one under here, there is one under here. So they're all over the place, as you can see, you know, hiding all over. So all of these caps have got to be removed and replaced. And it's also very important to locate the outside foil portion of the capacitor. So you can see on this capacitor here, we have a lead that's attached to the shell of the cap. So technically, if this is tied to the chassis, this is shielded right up to this point of the capacitor. And then of course the other part that's inside here is completely shielded because of this. So you can almost look at it like almost like coaxial braid right up to the end where the lead comes out. So very well shielded, and that's most likely the reason that they use these particular caps, because this is even better than a wax cap with an outside foil layer, right? So very well shielded, and these capacitors, the replacement ones that would be, you know, something like this, all of the outside foil on this has to be located so that I can attach that end, if it's a bypass cap, to the chassis, and this end is into circuit. So to give you an idea of how they were thinking when they did this, here's a clear example that the engineers were definitely told to do this. So I'll zoom on into a cap here inside, and hopefully you can see that. Maybe you can. Hopefully you can. Yeah, you can. Get that right here and prop this up. Don't move too much. Okay, so you can see this capacitor right down in here. So this is tied to the chassis. As you can see, it's pressed tight against the chassis. This is ground. And you can see that this runs right up to one of the IF transformers on the top here. And you can see how short this actual lead is right here. That's tying to the IF transformer. Do you see how short that is? And then you'll notice that on the resistor that runs up to this point, we have a very short piece of lead here, but they've left this end really long. So what they've done is in order to reduce lead length, what they've done is they've ran the resistor way down over here, and so they've left this portion long, and then this portion is really short, and this portion into the cap is really short, and it's shielded right at this point. And they've done that for a reason, right? Because they don't want any type of oscillations or interference or anything happening here, so they're keeping the lead length short at a point where it's very, very sensitive. And that's the reason that it's very important to locate the outside foil, because if we technically had this capacitor, see the replacement cap, say that this was the replacement cap, okay? So say we were going to use this, okay? This one's 0.01, so it's not, but just say we were going to. If we had this backwards, all right, so say that this end here was the outside foil, so this end is attached to the outermost portion of the cap. If we were to tie that to this point, all of that section would be exposed. So from here, all of this would be exposed to this point, and then the internal part that we would be tying to ground would be the wrong end. All right, so this looks like 0.01. So this would be technically the size of the replacement. You can see how much smaller that is. That's quite a ways away too. So when I'm replacing this, I need to locate the outside foil on this capacitor, so the same as the case on this. And what I need to do is mount this really up close to that terminal point there, up to this point here. So very little lead length on this side. We can have longer lead on this side because it's just tied to the chassis, right? But on this side here, it needs to be nice and short. So it'll be like this resistor here. We have long lead on this side and a short lead on this side. Well, there'll be a long lead to the ground point, and then a short, a short portion right here, if it would focus on the capacitor. There it is. So that's what needs to be done with all of these capacitors. Now, some of you might be saying, is it important for all of them? No, it isn't for all of them. It's just important for the ones that are tied to sensitive areas. So as we know, where the capacitors came in over here, right, on that terminal tie block right here, we have lead length running off all over the place here. So locating the foil end isn't so incredibly important on this side, right? Because, either end is going to be long. We have a long wire coming off here going to the power supply, and we have a long wire running off over here. So a little extra lead length isn't so much of a big deal. But when you're dealing with a sensitive area like that IF transformer over here, or any other area where the lead length needs to be short, that is very important to do. And if not, you're going to compromise the performance of your receiver when you're rebuilding it. So it's always a good idea to always locate the outside foil. That's what I do, and I just mark them off and install them at that point. So I'll show you that next. Let's locate the outside foil end of a brand new capacitor. Now, I get this question all the time, and the question is very valid. This is the question. How come they don't mark the outside foil end on these brand new capacitors if it's so important? And the answers are really quite simple. First of all, the majority of these capacitors are now going to be mounted onto a circuit board. They're not going to be mounted in a point-to-point circuit. It costs a lot of money to orientate this thing the correct way and perform another test on an actual production run. On a circuit board, you can have a ground plane layer directly below the capacitor that's acting as shielding. Whereas when you're building something point to point, depending on the builder and how this is installed, I guess you could say there's a lot more variability in the actual build. So really nowadays it would cost the company a lot of money to actually mark the outside foil end, whereas the customer or whoever is purchasing the component can very easily do that themselves with a device like this. Now, this is something I've designed as well as the capacitor tester here, just to make life a whole lot easier and to make sure that when I'm doing restoration like this, that I'm getting the absolute best results that I can out of the restoration. So I'll show you how this works here. So I'll clip this into the leads like so. So these are the test leads. And I'll just turn the device on. And you'll see the actual display is pulsing. So it's, pulsing there. And you'll see that there's two green LEDs moving back and forth. So the green LED on the bottom here is indicating which one of the test leads is grounded out. So this one is now grounded, this one is now grounded. The opposite lead is the signal lead. So technically what it's doing is it's taking this capacitor and electrically flipping it around so that we can locate the outside foil end. All right, so now to show you how incredibly important it is to locate the outside foil end, what I'm going to do is I'm just going to grab the outside of the capacitor, and just me standing here, the noise that's surrounding me, and basically, from everything that's around me, is going to be induced into this circuit, and you're going to very quickly see which side is the outside foil. Now you can see both sides are just pulsing right now because it's searching, right? So now, the least amount of LEDs that are lit in this row corresponding with the LED that's lit on the bottom tells me which side is the outside foil. So for example, I'll grab the capacitor just like this. Now look at that. Most amount of LEDs there, least amount of LEDs on this side. That tells me that this side is the outside foil. All right, so you see that? See how incredibly important that is just from me standing here. It's picking this noise up. Right, I move this down here. So this side here is the outside foil. So what I'll do is I'll take this capacitor, just like this. I'll flip it around, and now you'll see that this side here will be the least amount of LEDs lit with the corresponding LED on the bottom. See that? Now this side is the outside foil. Now, you can see how sensitive this is, right? It's very easily telling me which side needs to be attached to the chassis or to the lower impedance portion of the circuit, right? So just think about if this thing was in a chassis with an AC filament lead underneath it and you had put this in backwards. Or just say this is tied to a very sensitive portion of the circuit where there's an oscillator or something like that in the actual circuit. Just think, you know, you could create a parasitic oscillation or do all sorts of crazy things like that if this was not put in the right way. Again, point-to-point wiring is a lot different than mounting something to a circuit board. Now, keep in mind, depending on the sensitivity of the circuit that is actually built on a circuit board, in some cases, this can even matter on a circuit board as well. All right? So there we go. So you can see. So now that I know what side is the outside foil, right, which is this side right now, I'll unhook this and I'll hold this like so. And then what I'll do is I'll grab a marker. Now, not to deface the capacitor, what I do, hopefully you can see this here, is I just put a little dot on the end just like so. A little dot. And that now marks the side which would be tied to the chassis or the lower impedance portion of the circuit. And it doesn't deface the capacitor. I'm not scribbling on it or marking any, you know, lines or anything on the capacitor itself. Unless, of course, you're looking at the end, you're not going to see that little dot. And you can even use a silver type pen and it kind of blends in with the lead if you're concerned about that. If you're just concerned about, anybody seeing the little dot. A lot of the times you can even get a bit of alcohol and say rubbing alcohol and actually remove the dot if you want once this is in circuit, if that matters. But a lot of people actually want to see that so that the actual work has been done, so that you've actually done the outside foil location. So there you go. So both of these testers are devices that I've designed. So this tester and the capacitor tester, these are both available. All the plans, circuit board layouts, alignment procedures, drill maps, everything is all available in my Patreon electronics course. So if you're interested in building one of these things and you feel that this would benefit you in your repairs or your designs, definitely check out my ongoing electronics course. There's a lot more projects like this there as well. I've built many, many customized testers for many different types of, circuitry analysis and all sorts of things. One day I should probably line them all up on this bench here and show everything that I've designed. It would go from end to end. So I've designed lots of custom test gear there. So definitely check it out. And I'm sure you'll greatly enjoy what you find there. Let's take a look at what's hiding under this. This will also allow me to remove this cap. It's fastened right here. So and that is now on the bench. Oh, another cap is hiding under here. They're all over the place. Let's get this out of the way. There's another one here. Another one right down in there. So yeah, they're everywhere. So I needed to remove that anyways, just because, this end of the capacitor here is, underneath that shield. That allows me to move this out of the way. So lots and lots of caps to replace in here. So I'm going to get started on all of these. And once I have all the new ones put into place here, I'll explain what I've done. At this point, it's basically pick a capacitor and start going. So I'll start with this one here. It's relatively easy to see. So the first thing I'm going to do is heat this up and see if it's wrapped around this terminal very well. And of course, if it is, then usually what I'll do is I'll snip the lead short. If it's not, I'll just unwrap it and leave the lead on the cap, just because. So it looks like it may come off okay. So grab a pair of pliers here, put this on here like so. I usually don't like to cut the leads off the cap, just because down the road I may further test them. And I also like to save these capacitor bodies. You can see this one here is coming off. Now a lot of the times, if you're not worried about the cap, you can actually just snip the lead. This one here is wrapped around pretty bad. So usually they're not this bad. There it is. Look at that. How many turns is that? So there's that. I don't like to snip the old cap off and leave the leads on. You know, basically leave the remaining lead on there. It just makes for a very messy situation. As you can see here, it's kind of unwrapped this wire a bit too. I'll clean that up. So now, on this side here, you can see that. I may need to add some solder to this. No, that's coming off. Get that off there. A lot of people, again, as I've mentioned many times before, like to use the J-hook method. So basically what they do is they leave a little bit of lead and just solder to that. And I don't know, I find that that looks messy. A lot of the times you have to add solder to remove solder. And that's what I'm doing right now. Can't actually see which way they wrap this around here. So a lot of the times these things, they sink the heat off pretty well. And as you can see, this one here is no exception to that rule. There it is. So that gets rid of that cap right there, as you can see. Again, the seal looks like it's in very nice condition. Move this down here so you can see that. So one day, you never know, I may very carefully open this and restuff the cap, put a new cap inside. It depends on, you know, who wants the restoration done or something like that, right? So now what I do is I clean the area up. So this wire here is looking a little bit messy due to the removal of that cap. As you can see, this is very time consuming to do a nice clean job. So I'll just vacuum some of the solder off of this. Again, a lot of the times you have to add solder to remove solder. So what I'm doing by adding solder is I'm making a thermal connection between the tip and the actual part. And then by adding the solder, it makes it much, much easier to remove. So it allows you to clean the terminal up very nicely. And down here, I don't know if you can probably see that, I'm probably in the way. There, that leaves a nice clean terminal to resolder a new capacitor to at that point. So I have a whole bunch of capacitors marked at this point, so I've already marked the outside foil. I've done probably about 10 of them. So I have the focus fixed here so that it's not going to be focusing on my hand every moment. So you can see this is the outside foil end, so that would be towards the chassis. Now I can make this quite a bit shorter just because the capacitor isn't so incredibly big anymore, and that is actually a little bit beneficial. So the newer parts are always so much smaller. So you can put that on there like so. And I don't want to wrap this too incredibly tight, so I'll leave a little bit of slack there. You can see there's a bit of an angle on that. So I don't need to wrap this around the terminal post and get real crazy with this. Again, you know, this isn't going to be in a high vibration atmosphere, and that is enough right there to hold that. And with a very nice pair of snips, just snip away the access on that side. And on this side here, just pull that up to an area where I can get at that, like so. And re-add solder to this side right here. And then it'll heat the terminal up so you can just feed the solder all over the terminal. And there it is. It's looking pretty good. Nice and clean. One capacitor is in. I don't know how many more to go, so I'll keep on going. I'll tackle this one next and move to this one and move all over the chassis and get these all done. All the capacitors are in on the bottom side here. There was one extra cap that somebody had added, and it's on the cathode of the last IF amplifier. Maybe they added it to give just a touch more gain. So this is 5 microfarad at 150 volts. Let's see how that tests capacitance wise. So I'll put this on here and here. And it tests 5.3 microfarad. So capacitance wise, it's still good. Let's see what this tests for leakage. Move this out of the way. This in here. That's not going to glare. So it's on electrolytic here. So I'll put this here and this here, and we'll see what happens. So here we go. And that is leaky. Yeah, that should have been well green by now. So let's put a modern 4.7 microfarad capacitor on there. That would be the modern equivalent to that. So we'll go here and here. Quite a bit of size difference there, right? So here we go. So as you can see, that other capacitor, even though it tests okay for capacitance, it is electrically leaky and it is finished. So you can see where, having a tester like this, just using a standard capacitance tester to test capacitors could be very deceiving. And I see this all the time. All right, let's see what's under here. And more capacitors. Zoom on into that. So it looks like there are 3 caps that will need to be replaced. We have one here, and one right over here. Doesn't look really too friendly to get at, but I'll get these unsoldered and replaced. We're getting pretty close to doing an alignment on this radio receiver. New capacitors installed. Now I can get to installing the umbilical cord on the bottom side of the radio receiver. I'm ready to install the umbilical cord here. So what I've done is I've taken all the leads and soldered them all together with one wire coming off. You're probably saying, what are you doing? Well, I want to put this somewhat of a cable protector sheath over top, and that would look very era specific. So in order to put this on top of this entire thing, I need to pull this wire through because this is going to be relatively tight. So what I'll do is put this through one end like so, and this will poke out the other end, and this will allow me to pull. See, it's already out of the other end. This will allow me to pull this wiring all the way through. So I'll feed this up and over this like so. And you can see how tight that is already. So now when I pull on the wire on the other end, I don't know if you're going to be able to see this. You can see it's moving forward now. So I'll have to edge this through this entire thing and make sure all the wiring is going to cooperate. And at that time, this here should cover this entire wire, and that should look pretty good. The umbilical cord is now installed. It worked out really nice. So the coating matches the area and hides the wires underneath very nicely. So what I've done is I've put this into a rubber clip here. So it's a metal clip with some rubber on it. What I've done is I've put some super glue inside there, and I slid this up inside and then of course tighten this down to the chassis, and that is one piece now. That is solid. That'll never move. Isn't that nice and clean? Gets rid of that block on the back and just cleans this area right up. So one nice thing about restorations is it usually does a pretty good job of cleaning areas up. I've installed bypass capacitors in here. You'll notice that there are loops here. This is just a strain relief, just in case something was to ever happen and this was to twist or move a little bit. I don't want to put any pressure on the terminal tie strip. I want everything to, remain solid in here. So if anything is to move here, we have a little bit of room, and same with this as well. There's a little bit of room there. That's the reason I've bent this out like this. Again, another strain relief. So now what I need to do is I need to take these wires here and run them up here over around to this switch on the front face here. So I'll zoom you in on that. So I will wire tie these up. So I have some period correct wire tying, which I use the same stuff in the power supply, and I'll run this up and over just like this. What I need to do is I need to remove these two wires here and just bridge them together. So just connect them. And then these two will be the terminals that the switch wires go to. So this will switch just like it used to when this thing was flying around in a plane. So AVC will be on,
Good morning, here is Delta Oscar 9 Mike Kilo November. Michael from Germany. Hello, my friend. CQ. Echo Alpha 5. Golf Lima Tango. Felix from Spain. Can you hear?
Okay, good morning, my friend. There's Mike. Sorry, I don't. I can see your call. Sorry, my name is Felix. Fox Echo Lima, India. Sorry, from Spain, from southeast of Spain. In now in this moment next to Coac, next the Mediterranean Coac. Okay, back to you, my friend.
Yes, good morning, Felix. Yes, the weather is fine in Germany. We have 22 degrees. It's not more too hot in the morning. Yes, your signal is very clear, 5 by 9. Your packet loss is 0.5 percent. I can you a very good reading. Yes, Felix. Mike, back to you.
Okay. Okay, thank you for your report. Okay, well, yeah, and the weather is sunny, very nice day. I can see the sea, the beach. It's a nice, beautiful day in this moment. What about 24 degrees in this moment? About 24, 20, no, 20, 22, 20, no, sorry. See, 25 degrees in this moment. Sunny day, is beautiful day here in the beach, in the Mediterranean coast. Okay, back to you.
Yes, Felix. Oh, you go swing on the beach. I'm at the work. You take a little break. From the work, I'm working on the German railway, and yes, say okay. We make a little break. Look for the weather. Look for the contract for the next hours. And I say, oh, I will look on the DMR for people. And I have seen you have did a click and have say, okay, yes, I will talk with you. Felix, thanks for this QSL. Yes, I will confirm your sign on the QSZ.com and give you a yellow star. And I wish you a very nice day and very luck and very good swimming. And yes, 73, this was that Oscar 9, Mike Kilo November. Finally, back to
Delta Oscar 9, Mike Kilo November, er ist Foxtrot 4, Foxtrot Papa Zulu.
Foxtrot Alpha, Foxtrot F4, Foxtrot Papa Zulu, Jean Louis from France.
Ja, hallo Michael. Delta Oscar 9, Mike Kilo November. Hier ist Foxtrot 4, Foxtrot Papa Zulu. Ja genau, Jean-Louis, ja. Jean-Louis der Vorname. In Deutsch Hans Ludwig. 73, ich kann dich da sehr gut empfangen, sehr gute Motivation. Und wie du, ich bin da auf dem Arbeitsplatz und mache gerade ein kleines Kaffee-Break. Okay, Michael, ich gebe dir das Mikrofon dazu. Delta Oscar 9, Mike Kilo November. Hier ist Foxtrot 4, Foxtrot Papa Zulu.
Ja, guten Morgen, ich bin jetzt ganz perplex. F4, FPZ ist ja Frankreich. Und wieder mal ein ausländisches Call, der wunderbar Deutsch spricht. Das finde ich immer sehr schön. Wenigstens sind die Leute dann auch so nett und sagen, komm, lass sagen, sprech mal Deutsch, es geht. Ja, ist doch schön. Ich hoffe, bei euch in Frankreich ist es nicht ganz so heiß wie bei uns in Deutschland gewesen die letzten Tage. Hier waren wir bei 41,5 Grad und haben uns hier die Seele aus dem Hals geschwitzt. Ja, genau, wie gesagt, wir machen gerade eine kleine morgen Frühstückspause, bevor es dann wieder weitergeht. Und da habe ich gedacht, ich gucke mal, was so auf dem DMR los ist. Ja, danke, dass du mich angerufen hast. Und ich finde es immer schön, DMR ist so eine lustige Sache, so nebenbei zu kurzer Welle. Man kann immer mit Leuten mal direkt irgendwie in Kontakt treten, ohne dass man auf irgendwelche Gegebenheiten achten muss.
Delta Oscar 9, Mike Kilo November. Michael, hier ist Foxtrot 4, Foxtrot Papa Zulu, Jean-Louis. Ja, okay, ja, effektiv. Das Wetter da ist ganz etwas anders wie die letzte Woche. Letzte Woche war das ganz wahnsinnig hier in Frankreich. Wir hatten über 40 Grad. Das war, also die Nacht war 30 Grad und den Tag 40 Grad. Da kann man gar nicht mehr schlafen, wenn man keine Klimaanlage zu Hause hat. Das ist ganz okay. Und was man da hört, dass die Ende des Woche, also ab Sonntag, sollte das wieder also in Frankreich mal wieder anfangen. Ne? Und ich wohne da in einem Appartement und im letzten Stock. Dann da fängt es morgen schon mit 27, 28 Grad an. Da kann man die Fenster groß aufmachen die Nacht, alles machen, aber die Temperatur also bleibt im Haus, gell? Okay, Michael, 100%. Und ja, der Meer ist super. Da kann man eine QSO machen mit einer ganz kleinen Antenne, ein Hotspot und braucht man nicht so große Antennen aufs Dach machen oder Propagation warten. Also das ganz anderes, wie sagt man das? Also da ist keine, das geht ohne Grenze, gell? Ohne Grenze und mit für ein paar Euro. Okay, Michael, danke. Ich wünsche dir noch einen schönen Tag. Danke für das kleine nette QSO und warum nicht anders mal wieder? Hm? Delta Oscar 9, Mike Kilo November, hier ist Foxtrot 4, Foxtrot Papa Zulu.
Ja, Foxtrot Papa Zulu, der ist Oscar 9 mal Kilo November. Ja, das ist richtig. Und ich mache es zum Beispiel jetzt gerade, ich habe gerade festgestellt, meine HG, da ist die Batterie leer und ich habe Droid Star bei mir auf meinem Apple iPhone und mache das gerade ganz normal übers iPhone, über die App halt. Ne? Ist fast wie telefonieren, ist aber auch Ham Radio, Ham Spirit und das ist das Gute. Ja. Dann wünsche ich dir auch einen schönen Tag, 73. Wir hören uns bestimmt wieder auf 91. Und ja, dann macht hier DO9MKN jetzt QSE und muss wieder zu QL. 73.
DO9MKN, Michael, hier ist Foxtrot 4, Foxtrot Papa Zulu. Danke, ja, danke. Du bist jetzt in meinem Login qrz.com und ich hoffe, dass du auch das benutzt. Und ja, okay, wir werden uns wieder hören, das ist sicher. Danke, tschüss und cheerio, bis bald.
Ja, klar, habe ich kurz.
And then so the next year we'll go listen on to the Wi-Fi. Sorry, do you know about this one? Hi, morning, Mick. I'm M0SX Mobile. Morning, George. What's happening? Weather's a wee bit better today. So you just stayed in the Glasgow area, over? Aye, mate. Just sort of Charing Cross area then. And we're shooting up the way as usual, up to Alness. Roger. Oh, aye. Is there not a power station or something up there? See, associate that place with some sort of controversy over? No, I think you're thinking of Torness or something at the East Coast. It is East Coast, but it's 25 miles for Inverness up the way. Just before Invergordon. Ah, Roger. Right, okay. Aye, maybe Torness. Nuclear power station or something. Very good. Well, I'm just at Camden now. Just started really, so the van I was meant to be in turned up this morning with a flat tyre. So in a bigger van. It's just not too good because in the morning we need to just hit all the tasks fast. In this bigger van it's not as easy to do it. It's not got two doors and stuff like that, so anyway we'll just get on with it over. Aye, that's it, mate. You know all day what you can do. Aye, that's it, mate. So you heard anyone else on this morning, over? No, just the one grab, mate. It's a full load. There's actually two A's. The other guy, he's in front of me somewhere. Time at two is it loaded. I might catch up with him, I don't know. I need to stop and fuel up, I know, so I might go catch up with him. Aye, not bad. Yeah, it did give me a run yesterday. I'm saying that and I'll get back to 7 o'clock last night. I was up. Well, the furthest away one was Fraserburgh. I drove back on myself, which was Braemar. And it was quite exciting from doing all the wee mad roads, following the sat-nav obviously. From Fraserburgh to Braemar. Crazy roads, you know. But for some reason they're really, really quiet. But they were really, there was a couple of military roads I was on and a few, it was just following the sat-nav, you know what I mean? But it was, I literally the roads all to myself, so I wasn't hanging about. But as I say, still never get back to 7 last night, but it doesn't bother me during the week, you know what I mean? Not doing much else anyway. So, I want to watch CHINO yesterday, one of my customers. He seen the aerials in the van, he's like, "That's CD?" And I was like, "No, mate, it's his hand." He says, "I've got a wee present for you." And then he the office and come out with a VHF 2-metre handy in the box. Somebody gave him, thinking it was a marine band radio. Because the guy's got a wee boat, you know. Never ever used it. So here you are, I was like, "Oh, I'll use that." Just something for you. I'll just use that in the backyard and for listening to the radio, commercial radio, or 2 metres or something, you know. But nice wee, was it a moonraker? Obviously, it's not a moonraker, it's just a sticker on it, you know what I mean? But I cracked me handy, mate, for Nancy. Charger and all that. Oh, shit, that's brand new in the packet. It was like, brilliant. I'll get a wee bit of use out of that, big man. Thank you very much.
You are calm as well. And we can confirm each other. Thank you very much. I'm present to with you. Zero Papa Flat, Delta X-ray. This is Global Messaging in America.
Opened up maybe for Marine Bank for transit. I take it, well, maybe it doesn't. It's a bit of a kind of wider band receive. Well, a wee bit unusual, I suppose, just a moderate height. It's just water band, or is it UHF as well, Charles?
Zero Papa Flat, Delta X-ray. The Global Messaging in America. Yeah, I'm very present to with you, 73 to you and your family from Taiwan to Poland. And I hope, I wish you all the best to you. 73 today, 0 Papa 5, Delta X-ray. This is the Global Messaging in America. Thank you.
Minted, mate, brand new. Only thing is, he's had it for years. So the battery in it ain't speed. The Big Graham says that is quite common with the lithium-ion batteries. He says you maybe need to get a wee jump start to get the battery to start charging, because when I stuck in the charger last night, it came on but it wouldn't charge. So the battery could possibly be gubbed up, or it might just need a wee jump start. So we had last. Feeling that, I might end up getting a wee battery for it, you know what I mean, if I can still get them. So see, I'm not sure how old the radio is, you know, but it looks modern, but it could maybe, you know, be 2010 or 2000 or something like that, you know, the years, so I don't really know. I'll not know until I get a better look at it. But it's a nice look behind, nice and small. Small antenna as well. The antenna's only about 5 inch long. Maybe 5 watts, but 5 watts, that battery's lasting for about 3 minutes at 5 watts, Roger.
520, which will commence at 0830 UTC or 6:30 PM Australian Eastern Standard Time. All are welcome. There is another situation that Talk 91 is a call channel, and it's not a channel that you can talk on it continuous up to 15 minutes. So have a little bit of consideration to other amateurs that wish to call on Talk 91. Thank you. This is VK2GAP.
Okay, I think it's a 2000 milliamp hour or something, but maybe any phones with like the standard battery on the left, they set on standby for days, so they really good. So Hi Duke sent me a video last night of his software upgrade. So it was a software upgrade. His Motorola stuff. It's nice over my heat a wee bit. Oh, this was a terrible way to come into this fight. Oh, what the heck. Oh, crap, you couldn't hear it. That's here, Charles, that's not good. So, anyway. The postman's just got a flatbed for scooping up bikes, so he is. So we'll see how that goes. Hey, I better go clear just now after we arrived at this job. Maybe catch you on if you're on through the day. George, MM0SAX, MM7SQ.
You, Alfred? I'll maybe hear you later on, mate. I'll be in range of the Inverness repeaters. So, I should be up there for about 12:30 before I'm in range. just because you're a lay of the land, you know, with the internet. You literally need an internet before you get the repeater. So, I'll give you all a couple of shout-outs when I'm up there, mate. You have a good day, Mick. And I'll say 73 catch later on there, and then 0S6 mobile clear. Ta-ra. Australia is always nice takes for me. Thank you, Alfred. Send my America to you and your family. PK to Golf Alpha Papa from Yankee Golf 1 Romeo Alpha Whiskey 73, my friend.
RAW, Agostinos, or Denny, whichever you prefer. Nice to hear you from Tangerang, both Parton in Indonesia. And I can't hold it anymore because I've got to do some talking on this one, and then I will QSY to 50520. So thank you very much, okay, Agostinos? And maybe you would like to join the net at 6:30 on 50520 if you can. So 7 trees to you and your family, Agostinos. And we hope to catch up with you again on the net or other means. In other words, with the groups. Cheers, my friend. YG1 RAW VK2GAP. Cheers, Agostinos.
Roger. Also, thank you for nice KSO. Send my America to you and your family. 73, my friend. Thank you. I will love you again. Thank you, my friend. 73 from Yankee Golf 1 Romeo Alpha Whiskey clear with you.
Okay, Agostinos, before you go, I am going to log you into QRZ.com if you don't mind. Okay, Agostinos? 73, my friend. This is VK2GAP signing.